I've low-key lost my voice. Like, I can't talk normally. So I'm kind of have to talk like this, but I guess it isn't too bad. It does mean that I can do some pretty deep stuff. Buddy, you think you look strong? You're wearing a cape. Here's a cheap fucking knockoff. But I was on the toilet this morning, as you do, and I found this article. Let me just open it up real quick. Oh, holy congestion. Okay. Oh, okay, we're back. I think I'm back. My voice is restored. Kind of. Oh well. But here it is. It's a thing called Obscure Obsidian Features. C++ features made by Evan. So what? I saw Obsidian somewhere. I guess I just misread Obscure. Anyway, so actually, last night, just a little side note, I was on Twitter, looking at like different programming accounts, because I asked Claude, yo, where's the best place to, you know, for like programmers, and they said X, Twitter, obviously GitHub and stuff, but like, you know, for like actual social media, like that isn't like LinkedIn or whatever, Twitter, also Blue Sky, but Mastodon I've seen quite a bit, but apparently Mastodon has like kind of lost popularity. To be fair, that this article might have been posted like, well, there's no date, but it could be old, because I know like Mastodon was hyped back in the day. I mean, yeah, like this guy has stopped posting since 2024, so. But hey, maybe they're on Twitter as well. I don't know. I know a lot of people left Twitter. Personally, I don't care. Like, unless the site comes like plagued with ads, or like some other site that comes along that's like genuinely better, then I don't particularly care too much. Yeah, I don't see him here. I'm following low level, right? I should be. There's literally nothing wrong with GoTo. Oh yeah, actually this too. I don't code in C, but W GoTo. Sometimes I do wonder about using GoTo, but I guess if you can get away with not needing it in C++, that's a better thing. I'm not following him. Fucking hell. Now I am. But yeah, hopefully my Twitter feed becomes actually like usable then. Because right now all I get is like fucking these posts from like Discord and Mr. Beats and like shit I don't actually care about. So anyway, this page is a collection of obscure. Let me zoom in here. We're trying to zoom in. Can I move myself to an optimal position? Just read there. Okay, right. So I just did a quick Google search, like on the toilet, saying what are some obscure yet useful C++ features. So let's have a look, and hopefully we'll find something pretty cool. I'm already aware of like a few cool obscure things that people don't know about, but like I want useful things, you know, not just like your random fucking thing. Yeah, this is Evan Wallace, sorry. Go, JavaScript, Swift. He's got doesn't seem to have a link to any like other blog posts, but oh well. Anyway, this page is a collection of obscure C++ features gathered over the years as I've explored different corners of the language. C++, oh, I guess this isn't a blog post per se. C++ is very big and I'm always learning more about it. Hopefully you learn something from this page, even if you already know C++ pretty well. The features below are roughly ordered from least to most obscure. Actually, it'd be cool to make a page like this for something else that I'm learning. Like, I have all these Obsidian notes, but like there's some things that would be pretty useful to like collect into one place. Publicly, maybe. So, square brackets, yep, I know this. This is devious. I don't know why this is allowed. I mean, I know why, but like I don't know why they've like enabled it to be allowed. But I guess it just simplifies things, and no one in their right mind would do this anyway. So, most vexing parse is a term coined by Scott Myers. I've heard about this. Where the ambiguity in collection syntax leads to counterintuitive behavior. Right, which is why we just use braces, right? The curly braces, which this guy doesn't seem to acknowledge, I don't think. A variable of standard string initialized to a standard string. Or, hold on, let me read this. This looks like a variable that's being declared with an empty string. So a string that's being declared as an empty string. A variable type standard string, such as string, or the declaration of a function that returns a standard string and has one argument, which is a pointer to a function with no arguments that returns a standard string. Right. Yeah, okay. I guess that could be the case. But like this is like functions aren't allowed in global space. Oh well, to be fair, you would be allowed with this. Anyway, is this a variable of type int initialized to int x, or the declaration of a function that returns an int and has one argument, which is an index? Yeah, for some reason this is, you can define arguments like this, and you can have as many brackets as you want. I don't know why, I forget why, but yeah. Okay. So although the first one is intuitive, the second one is overridden. And honestly, that's fine. I'm fine with that because you shouldn't be using. You should be using braces anyway. So. But okay. Otherwise, you can just double up quotes. Sure thing. Oh yeah, this is cool. The tokens and equal, bit and all these can be used instead of the symbols these. They let you type operators on keyboards that lack the necessary symbols. Honestly, I have debated using these, not these ones, but I have debated using like and or, because it's like, oh, also not equals. That's pretty cool. Just because like I don't love just using these different symbols. Like let's have a look right now. If I were to open up my C++ library in Neovim. And go to random file. Well, that's CPP one. Let's do reader. Oh, I didn't read the error there. And I mean, I don't know if I even use it. Oh, is there not as well? Didn't see that. There is not. Yeah, like instead of an exclamation mark, I did not. Data is at end. I kind of like that. I might actually just like start using it. As long as like it's not deprecated, because that's also possible. Tell you what, I'll use it in the next C++ project I make. So not this library, but like if I do something else, I'll use it. So like basically my first non-library project is what I'll do it in. In Rust as well. I don't know if Rust allows the same thing. Does Rust allow and instead of double that? I'm guessing not. And C++ and alias. And keyword. I assume they're not deprecated. They aren't. Awesome. Like, why would you not use this? Honestly, it's kind of cool, isn't it? Another fun fact about this, and for God knows what reason, also functions just as the double and in general. So you can do it for like reference arguments. Like if I have a function, if I have a function that's like int foo, which takes an argument int double reference x, like this, right? I can literally do int and x, and it would be equivalent. Except in that case, it makes no sense for it to say and, because this doesn't mean and in this context. So like this is kind of stupid, but it's funny. Redefining keywords by the preprocessor. Yep. Placement new is an alternative syntax to the new operator that runs in place on an already allocated object, which is assumed to the correct size. Where's that? Alternate syntax. Am I seeing it? Oh, it's here. Test pointer equals test malloc size of test, then a new using that pointer test. And then you must call the destructor yourself. Huh? I don't use new enough to really understand what this is doing. It's using writing custom allocators for performance critical scenarios. Okay. Yeah, I really don't use new like ever. So, branch on variable declaration, syntactical shorthand for simultaneously declaring a variable and branching on its value. It looks like a single variable declaration. It can go in the condition of an if or while statement. Where's that? Declaring and branching on its value. Is it like when we used to find a variable like this? Yeah. It's saying that if the pointer is not null, right? Yeah. I'm aware I'm aware this exists. I just don't like it. Yeah. Yeah, I don't like it. But I mean, it's something you can do. But I just don't feel like it makes you think of like if let in Rust, right? But like just not easy to read. Requalifiers on member functions. C++11 allows member functions to be overloaded on the value type of the object that we use for this, using a ref qualifier. Oh, like this. Yeah, so this one I found out. Well, actually, I didn't know it worked for this one as well, but this one I found out for my library, because I wanted like basically a singleton that is never actually initialized. You just call it like kind of like statically, but not necessarily, if that makes sense. Like it's a class where you only ever call one function from it, and that's it, right? And then it's never constructed. Which is quite a useful pattern, honestly, and I'm surprised it's not used more often. But yeah, foo prints an rvalue. Like, see how like this could be static, but what is useful is if you have like a state that you want to maintain the whole way through. So yeah, I don't know. I think it's pretty cool. And you have foo prints an lvalue. Oh, I see. It also allows you to overload, right? Okay, that makes sense. So I don't use it for overloading. I use this to restrict it so that you could only have this rvalue call. You can't ever construct foo like this. Well, I mean, I guess you can. Actually, can you? No, you can't, because the function to call for like the parse function in my case only exists like this. Yeah, that's cool. This though, overloading on L value. I wonder why you would do that. True complete template meta programming. Yeah, this shit's whack, but it's a thing you can do. I'm guessing constexpr and reflection will both go hand in hand to finally make this obsolete. So like you don't ever need to do this, but it is quite cool. But also something you probably shouldn't do. You know, for like serious code. It's recursive. Struct factorial enum value equals n times factorial n minus 1 value with a base case. Yeah, it's interesting. CPP templates can be thought of as functional programming language since they use recursion as an iteration. I have no immutable states. Data structures are embedded in types themselves. Wow. And who said that C++ isn't a functional language? Is that a linked list? No, it's a list. Yeah, goddamn. No one could have seen this coming. This is literally like fucking how you would construct a list in Haskell as well, which is kind of wild. Well, these examples are pretty useless. Anyway, some useful things like manipulating lists of types. However, the programming language formed by C++ templates has trouble usability. Yeah. Oh, is this supposed to compile? I thought it'd be fast. Be a hard to debug, no surprise there. Shit, I'm out of water. Pointer to member operators. Pointer member operators let you describe a pointer to a member on an instance of a class. There are two pointer to member operators. This for values, nested pointers. Pointer function. What the hell? How's it being namespaced? In struct, I don't understand that. That's interesting. I didn't know you could do this. Like an alias? Yeah, like it literally becomes part of the thing. That's crazy. Why would you use this? Writing libraries. Boost Python uses a member pointer to easily refer to members when wrapping objects. For like function pointers. I mean, I get that, but it's the namespacing that's whack. Keep in mind they are different from regular function pointers. Okay, so casting is not the same. This call. Is that still true? I find that's about outdated now for 32-bit architectures. I mean, for Intel anyway. Okay. Same methods and instances. As you change an instance method to a setting method that needs to update any call sites. These are equivalent. Is that a constructor or? Okay. That's interesting because this mirrors the syntax of having the rvalue thing from earlier, right? Which is cool. Overloading plus plus and minus minus. Oh yeah. Number operator plus plus. Prefix and postfix. Except it doesn't actually do anything. Like I don't think you have to use this, right? Where have I seen plus plus used? I think you can use it for like iterators. I've seen it used there. That might be it. But yeah, it's interesting, isn't it? I could use that for my binary library, but to be fair, there's not really much of a reason to. Operative loading and evaluation order. Bro, other than the comma operator is devious. Print, this is a test. The sum of A and B is A plus B. Where is that being overloaded? Define print, hidden print. I see. So it's calling this. Oh, it's a namespace. Yeah, sorry. Space false. Interesting. What is overriding the? That's weird. How's it overriding the need for parentheses? That's what I'm wondering. That's kind of. Is that just because of this? Functions are simply parameters. Hold on. I feel like I need to test this out. God bolt. Say I use print. You know, standard print line. Actually, define print as standard print line, like that, right? So if I say print hello, compilation failed. See the output window. I'd like to, if it should be it. On C++, let's say 26. Where's the output window? It's not like actually showing me it. What? It's like a secret fucking tab. Expected thing after expression unused. Right. So how the fuck does this work? Oh wait, it's a comma there. What? What? How is it passing the arguments there? Oh! Right, because it just calls a constructor, ignores it. No. Well, yes. Yeah, I see how that works. That's fucked. Okay. Functions and simply parameters. What the hell? Why? Memorize. I mean, actually, I guess it's the same as just passing as an argument, right? Wait, what? This automatically memoizes. What? No, there's a map here. Except it's... Oh, static, okay. Okay, whatever. Template parameters. Why? Okay. Function try blocks. Oh yeah, this I've seen. It's for constructors, right? Where like if the constructor throws, then you can catch it. Actually, can you return from a catch? I assume no. But that'd be a good way to like solve the issue of constructors in in general. Available for all function definitions. Strange. That's it. Okay. So not super obscure, to be fair. But it was interesting. I want to look for like C++ standard library features. Obscure. Specifically for the standard library, you know? Let's have a look. Fucking hell. This is a talk, right? Damn it. It's actually, yeah, so this, I mean, this whole thing for me was inspired because I found out about standard unreachable, which invokes undefined behavior, and like it just made me think like what else could be hiding away. I saw that I've already seen this, or like, well, at least I've peeked it. I do not understand what standard launder actually does. There's like some weird thing where like if you call new with this, for some reason that like what does this even do? I don't understand. Like somehow this is equal to 3 because like we're laundering base and transmogrifying it, which like it's not returning it. So like how is that? Yeah, I'm very confused by that. Oh yeah, and this was with the keywords, with the and and the or. Very, very cool. And then this thing, where you can do where to say? I don't know. Here, yeah, int and r reference. Okay. This doesn't work. Attributes can bounce back into them and even other arbitrary tokens. Why? What the hell? Right, so this is what I was saying about like any function, not just a constructor. So that's cool. I mean, is it cool? I don't know when you'd even use this. But it works without a body as well. That's kind of interesting. Like I get it for constructors, but like why have it here? Is it just to like if I throw it inside a function body, then it'll do something? I guess so. Parameter pack expansion. Const auto params. Oh, like this. Is it obscure? I mean, he said it's not. He says lesser known. I mean, I feel like it's kind of useful now. Like, you kind of need it. Although here they're using auto instead of using the fucking type name args, whatever. But yeah, I'm aware of this. I just never used it. Like, for like variadic arguments. You could do it for a list of sorts, like defining a list, or you could do it for defining a like a print line thing. Oh shit, I'm almost 7%. I really need to like set up my fucking battery thing so like it warns me when I'm low battery. Also, my battery drops even when the computer's off, which is a problem. I need to sort that out too. I do wonder, like in languages like I think Zig just uses like a list, like an actual list. So like you have your format and then a list of arguments, like an array, which I think is probably better. Rust uses fucking macro, so it doesn't matter. But anyway. Nested templates. Don't know why you do that. There's 2 standard moves. Wait, what? Move cast the arguments of our value reference. Actually, I kind of want to figure out how move actually works. You know? Like what does it actually do? Produces an X value expression. Is equivalent to static cast to an R value reference type. What the fuck? So how does that work? Oh, okay. So if I define a function, is this implicit? This R value instance of it? Maybe. It tells the compiler to use the latter. If only the first version exists, that will work too. R value binds to both forms. Okay. But prefers the second one when available. So like if I have a string as an R value, I still don't understand how that fucking works. Holy shit. This is a big one. Viewed 686,000 times. Definitely a hard common thing for fucking C++. Yeah, I don't really understand R value references either. Like I thought R values were like just like basically like literals. Like int x equals 5 is an R value. That's how I understand it. But I'm thinking that's probably not correct. An X value, so not an R value. You can plunger me, move anything I'm holding, use it elsewhere. It says I want to be destroyed soon anyway. Right, so an R value is destroyed. So it says a compiler. Another object owns it instead. So like if I standard move on a vector, and then try to use the original vector, would that be undefined behavior? So it's a compiler thing. Okay, so for L values, okay, so an R value is a PR value or an X value. I see. X value is for expiring. It is a GL value that denotes an object whose resources can be reused. A is an R value. B is an X value. Oh my god. It's blown my mind.
So, welcome.
Well, this is a talk I just saw, right, on the website.
Let's get started. I already gave this talk at Italian C++, where I received some feedback, so just a quick disclaimer. Someone has said he liked the talk and discovered a lot of new features, but somebody else said the features are mostly bad practices. The statement, you can omit the braces. So you can write something like that. This is a switch statement that contains a single statement, 3 labels, and then this is a separate statement that's executed all the time. Right? So that is pretty cool. You can also combine the switch statement with other control flow statements. So this is a switch that sort of had a merge conflict with an if-else. And now we've got an if I is equal 0, but that one's never actually executed because if I is 0, we jump to the case down there and execute that one. And this can be all combined to create this beautiful thing. You might have seen this, stuff's double. Can fit a 48-bit pointer in NaN. So it can store everything inside a single floating point value, and it's either an actual number.
Fun talk. Move semantics. This is literally a fucking. This is Bjarne's thing. Bjarne is. Yeah. So reference can be an L value or R value. L value, that's R value. So an R value reference behaves like an L value, except it can bind to a temporary, which is an R value. So an R value is different from an R value reference. Yeah, why on earth would you want to do it? So like pass my reference, like fine, like it's pretty much just like a pointer. But with this, is there a way to visualize this with pointers instead of using double ampersand? Maybe not. Okay. So a double ampersand R value can bind both a reference, an L value, and a temporary, like literal or something like that, a value, value. And then it says non-const as well. So if it is const, it doesn't work. and it gives move. Okay, so eliminating superior is copies. Copy can be expensive. For example, standard vector. Yeah. T temp A. It's not a keyword, is it? A equals B. B equals temp. So if we don't want copies, we can just use standard move on an L value. It gives target the value of its argument, but is not obliged to preserve the value of its source. Right. So yeah. So it is kind of just like a nod to the compiler optimize then, if I understand it correctly. Remove reference T. Yeah, I've seen people forwarding. So do I understand correctly when I say that standard move in C++ doesn't actually move anything itself? Instead just nods to the compiler that it can optimize via a move, and it does so by casting something to a R value. So this is equivalent. So can I? What's weird though? In my library, I don't use a double reference. In my arguments, I just use like a value. Like I'll have like a standard vector. So can you break down how this is supposed to work? So say I have a void foo that takes a standard vector of ints, whatever. No, I'm thinking of a constructor, aren't I? Yeah, no, I'm thinking of a constructor. Okay, in that case, a class foo that, or struct, that has an int, not an int, a standard vector int v, let's say, and then we have a constructor foo that takes a standard vector int v, and then v is a standard move of v. And then int main standard vector int v2, or like whatever, call it b, and then foo b. Like here, it looks like I'm passing b as a value. So I'm wondering how this is supposed to work, or is it just a way of just copying it, of like not creating a copy when I move it here? My assumption is that in this case, b will be left intact, but this is just optimized so that this isn't copied here. It's just moved there immediately. But then I wonder in what instance. Sorry. But then I'm wondering in what instance is B actually moved, like B itself. Like, is that only when I do this? Is it only if I do this? Like, what's going on here? So this is an L value. So it's copied. Okay. If I wanted 0 copies, I'd do this. Okay. And the caller must standard move it. Or use perfect forwarding. Does this 0 copies approach leave B as empty? Okay. Does the caller still explicitly standard move for perfect forwarding? You know, I do wonder. I know Rust has like move by default, whereas C++ is copy by default, which means it's easier to accidentally copy in C++. But when you know what you're doing, I don't know. I suppose it matters less. Because like, how often do you really want to move? But like, Rust has like this concept, this idea of borrowing, which like conceptually is, I guess, cool. Okay. Oh. So basically, perfect forwarding just gives you like a free overload. I see. So you can move, or you can just do that. Oh, right. So I should really be using this in my library then, I feel. Because like, if you look at my code, say for the reader, I don't know. Not the reader. Like, say for my chunk. Where do I actually use this? I think here. Like here, I'm using standard. Never mind. I'm not moving at all. Like, what it's saying is that if I want to use that, what do I use standard move? I thought I did. I definitely do somewhere. Do I not? I mean, I use this forward here for the error, so that moves it into the struct. So we just avoid a copy there, I think. But then you still have to standard move it, right? Man, what the hell? Well, now I'm tweaking because I thought I had a standard move somewhere. But apparently I don't. Perfect forwarding. Okay. So perfect forwarding will either pass by reference or by rvalue. I see. So if I pass like a string literal, then it's fine. If I pass an existing object, it will copy it. Okay, that's fine. Because like when I call errors from my library, I do it as literals or references, which is, oh no, because it copies. What? It forwards it until what? T, the variant. Why is it not a const? Why not use a const t? Because like if I don't want to modify it, it would reject rvalues. Const t and okay. Why does const t reference capture bind to everything? Anyway. Cause like for these errors, I'm never modifying anything. And like this const is useless anyway. Oh no, it's not actually, because I have a different thing here. Well, is it useless? I guess it is actually, because it's, yeah, it's not used anyway. Like here, I just take a path, and then I standard move it. So like here, what's happening? I'm not actually. Like it creates a copy of the path, which is a good thing because I don't want to steal it. But then, like, why not have like a reference to the path instead? Like, should I use this or should I use forward args instead? It's special cased, so it's not exactly intuitive then. That's annoying. Before our values references exist here, this was the only way. Shit. So it's not actually a const reference. I mean, it can be, but it can also be other things. Bruh. So, say I have an error an error tagged union, and want to pass a standard file system path to one of its error types, a struct. How would I set up the constructor? Well, that's what I'm doing right now. Right. So, if the caller wants to move it, they can if they want to. One copy, one move, one move, one move. And this just moves it. The difference is minimal for a path. It's cleaner. I love the word perfect forwarding. It makes you think of like perfect cell. If you're not perfect, then you're not me. Oh wait, my voice is back. Hell yeah. I don't know why. I don't know what happened to it. Maybe my voice box is just fucking still sleeping. Can I still do the same thing before, buddy? You think it looks strong? Maybe. What makes zero forwarding overhead? And if it is, besides bloat, like provides verbosity, why use standard move over it? Yeah, so if I didn't care about the path, I could just move it. So I'm trying to think right now. When do I have an error? Unrecognized? Like, that's a standard string, right? So I could standard move that. Hold on. Implicitly converts. Construction. Is the implicit construction, is that a fucking copy? With by value, you still have two moves. What if the path was instead a standard string? Oh. What? It tries to construct a path from an int. That's not good. Right, because it forces... Oh, yeah, because so... I remember now. What perfect forwarding does is it forwards the constructor as well. So it will literally try to fucking call the path constructor. Moving a path of vectors is pointer swaps. I see. Okay. So when do I use standard forward? Yeah, I mean, this is the most common pattern I see, where you literally just forward it like that. And the reason I use it in my error handler thing is because that's what you want to do, right? You want to just forward it. In place style functions, where you can constructing in place. Yeah. Middleware decorators, so like lots of just variety arguments. You don't own them, just pass them along. Okay. Interesting. So, hold on. I use move for that. I use move for that, for there. So if I wanted to be optimal, I mean that's a small string anyway. But let's say for my unrecognized, I think an xfbin reader found a swap file. Why? Don't understand that. Right here. So, I mean, it's here in this thing. here, temp.error. But it's temporary. So it's already an R value. Interesting. So does that mean I don't need to standard move this because it's already that, right? So let me copy this. In that case, what do you make of this pattern? Okay. Yeah, temp is temporary, so that's the right call. Auto is essentially perfect forwarding for a local variable. It's a forwarding reference that preserves the value category of whatever expression evaluates to, avoiding an unnecessary copy. So there's no, is there ever a need to standard move temp.error instead? Okay, so in general, yes, that I understand then. In this case, so is that because I'm already doing auto reference? No. From is expressing a new object from it anyway. True. True, but what if I want from, which returns an xfbin error, to own that data? Yeah, so should I not do that then? It's a variant, so it could contain, well yeah, it's a tagged union, so it could contain data sometimes. So I should then, okay. See, in Rust this will be automatic, which is, you know, obviously it's makes it easier, but I feel like it can also be dangerous because then like people don't know what they're doing necessarily. Very, very interesting. So here I have two standard moves. Interesting. So like really I should be like moving these two, right? What about for something like this? And in the meantime, let me just see if this actually compiles. It's const. So then I have to drop the const. Do I still need to drop the const? Is it possible to not need to drop the const? Since idiomatically. Well, I guess not. Because it's being moved. Like in Rust, you move constants all the time, right? So is it possible to keep the const? It compiled. And it runs. Moving counts as a copy, okay. Yeah, so in this case it's only 4 bytes. So moving would be pointless here. Damn, so like that's like a real decision I have to make. It's kind of whack. This try thing, it moves both, but that might be wasteful because it's mostly moving like U32s. But like it's just that it could be not a U32 instead. I don't know. It's very interesting move semantics. Some standard move shenanigans. Okay, I really need to read more into that, but at least I understand what it does now. Maybe. I'll have a quick look. C++ standard move. Maybe I benefit from watching this video. I think I've already seen the trainer video. But I really need something more like in depth. Move only function. Have a look.
So, welcome ladies and gentlemen. Welcome to Back to Basics Move Semantics Part 1. I'm Klaus Zettelkasten. You can consider me your guide into the realm of move semantics. So, I kind of expect there's 2 groups of people. The first group of people is the people who potentially do not know move semantics yet or still struggle with the details. This talk is exactly for you, so you are very welcome. But there's also another group of people, probably, this is the guys that already know about move semantics, potentially even know more than I do. Okay, you're of course welcome too, but I have a request. So I have a couple of interactive questions. At least give the other group 3 seconds to think about the question and then give it away.
How loud is the wind from my mic?
Is it okay for you?
Holy background noise suppression. 0 of it.
So now if you counted the 3 in your head and then said yes, we have a deal. All right, perfect. So, short introduction of myself. So, as I said, I'm Klaus. I have been a C++ trainer since 2016. Additionally, I'm a senior software engineer at Siemens. You might also know one of my work. I'm the author of the Blaze C++ math library, and I'm also one of the 4 organizers of the Munich C++ user group.
Okay.
Which, by the way, is truly an amazing group. If you haven't been in Munich anytime, check it out. Fascinating group. I'm also a regular presenter at C++ conferences. So this is a talk in 2 parts. In the first part, we're focusing on the basics. We talk about the basics of move semantics, the new special number functions, and parameter conventions. Later in the second part, we dive into the details. This is where it gets perhaps a little gory. All right, I have a couple of thank yous. I want to thank Nikolai Yusutis. This is the 2 guys I learned move semantics from. So if you have the opportunity, check out the teaching material. This is really great. And I also want to thank Howard Hinand. He is kind of the mental father of move semantics. So if it would be if you would,
I recognize that face.
Wouldn't be, then I wouldn't have anything to tell you today. All right. Let's first of all motivate this. Let's go to the real basics. What are we about to do? Let's imagine that we have a vector of integers. Quite simple. This vector would be represented like this. The vector itself, the static part, is just 3 pointers to int. There's a couple of addresses, of course, and then there's the dynamic part, 1, 2, 3, 4, 5. This is somewhere on the heap of restore.
Okay.
Now I have a second vector, v2. It's empty at this point. So at this point it is just just the stack part. All the addresses have been zeroed out, all the pointers. Now I assign v1 to v2. Now what do we expect to happen? Oh, question.
Copy.
All right. The question is, what are the second 2 pointers? So by
I love it when people in a doing a lecture or doing a talk, when they hear a question, they repeat what the question is. I was watching back some of my lectures from this past year, and sometimes someone will ask a question, but the question isn't repeated, so it's like, what the fuck? What literally their response doesn't make sense because you didn't hear the question in the first place.
the way, if you have a question, please anytime, but preferably use the microphone. It's much easier, much better for the recording. And,
Well said.
Of course, then I don't have to repeat the question. The second 2 pointers. So the first pointer points to the very first element. This is the begin pointer. The second pointer basically represents end.
Good question.
And the third pointer, in this case exactly the same thing, would represent the very end of the memory that you have. This is something you could use to compute the capacity.
Yeah.
All right. All of them.
So a vector is just 3 pointers. I mean, also not just, but as far as its members, I guess, goes. I mean, I'm not surprised, I guess. I think the real difficulty in implementing a dynamic array comes in the reallocation, right? Like if you need to increase the size and move it somewhere else in memory. I wonder how that works.
0.
I should probably try implementing 1 at some point.
To v2. What we want to happen in this case is something called a deep copy. We want to have an exact replica of v1.
Okay, let me actually write some of this down because it's quite important. I mean, throughout my days, holy shit! What, I have 9 pings and 8 here. Is it a bot? Hold on. So this is the actual topic. What the fuck happened? Oh, they just pinged a role that everyone has. They're getting smart. That's annoying. Man, that actually is quite annoying. Because on Discords, you can't restrict who can ping what role. Like a specific role. So if you have like a ping for feedback role, or like a ping to play this game role, right? Like you rely on moderating those who misuse it, but if it's a bot, then that means you're just gonna get spam pinged, which is annoying. Oh well. Anyway, Obsidian, create a new source note, and what's this? Back to basics. Okay, let's copy that. So the link is here. Video ID is there. Wait, part 1 of 2. Oh, I see. So there are two of these. Well, so is this like a common thing, the CPP rep, the like back to basics thing? If so, that's pretty cool. So where's the sequel? Because here he talks about the first part, right? Yeah. Okay. And it's only an hour long, but that's good, you know. Like it means to be in depth. Damn! Look at all that. Also back to basics, yeah. This is for 2019. Shee. Where's this link to? This is a PDF. This is just a PDF. Yeah. Okay, that's cool. I'll see if I can find links to the other things, because I do want to go through these talks at some point. But anyway, so this is Move Semantics, part 1 of 2. What's invalid here? // : Oh, here. Back to basics, Move Semantics, part 1 of 2, Klaus Egeber, CppCon 2019. That's actually fine, I think, as a title. Let's call it this. Authors: Klaus Egelberger. Definitely not how. That's not his name, is it? His name has Oh no, I think it's someone else. Yeah, Klaus Egelberger, CppCon. It was published on the 20th of September. I would like to go to a CppCon someday, but yeah, I mean, like, just to, like, support, you know, because, like, obviously you can watch them online, but I think first of all there are some exclusive ones, and second of all, you know, if people stop showing up in person, then the whole thing kind of just dies. So online video, but it's also a talk, like a conference talk. What kind of media type is a in-person talk at a conference like CppCon? Yeah, conference talk. Recorded presentation. Conference presentation. New tag unlocked. Alright. And the preview, just this. Oops. Okay. So that's the video. So hold on. The real basics. A vector can seemingly be stored as just a pointer, as just 3 pointers. 1, start of the data. 2, end of the data. 3, end of the capacity, before needing to reallocate. Well, to potentially reallocate. And oops.
And this is absolutely reasonable, because if we want to have, this is something you could use. The second pointer basically represents, of course, then I don't have to repeat the question. The second 2 pointers, so the first pointer points to the very first
3:32. Okay, and then you talk about deep copying.
element. This is the begin pointer. The second pointer basically represents end. And the third pointer...
What the fuck? What the fuck? This is a joke. It's not April, is it? Hold on, guys. Eyes of Heaven are? What the fuck? What? It's actually happening. We're getting Eyes of Heaven R. There's no fucking way. Hold on. What the fuck is going on? JoJo's Bizarre Encyclopedia. I guess this is an ad to everyone, right? No, game announcements. Oh my god. Switch 2, PC of course, 5, Xbox Series X. Okay, so it's like HBR, just like being like cross-platform. Was it leaked or what? Holy shit. There's no way. Holy, I mean, good timing that I'm recording too, because I wouldn't want to capture that. That's what the fuck. Yeah, because like this happened like last year, and you're like, okay, like they fucking patched the game, but they've actually announced Eyes of Heaven R. Is there news on this? No. Yes. Richard in Brazil. So this is a leak. It's a leak. Yeah, it hasn't been announced yet. Oh my days! It could be. Could it be fake? No, it's real because it's on Switch 2. To clarify, dude, look at the reactions on this. To clarify, this is a leak. But very likely legit, considering we're very likely legit and not just a typo, considering it's releasing for Switch 2. Oh my days, man. That's insane. Oh, I wonder when they're gonna announce it. And like, will it have Steel Ball Run stuff? Surely. Man, this is the year. This video got so derailed, but like, oh my days. I mean, it makes sense. Because like I was thinking like surely they would release some kind of game to go alongside the Steelable Run release. And then we had the announcement of, well, first of all, Aura Overdrive, the mobile game. But then the other mobile game, which was Golden Hymn, I think that was called something else. I can't remember what it's called. But like I didn't expect a new PC game. Obviously, you know, it would be nice if we got like an actual new game. But Ice Heaven R is very welcome. Oh my days. Shit. So now it's been leaked. Surely we're gonna get an announcement soon. Summer Game Fest. Oh yeah, that's happening. Hold on. When is that happening? Why are people complaining? Bro, shut up. There's a panel, Anime Expo 2026, July 3rd. Fuck! So it's like a month away, but oh my days. This is huge. This is massive. Big news for the unemployed, but like generally like you know, I got into C++ and modding because of the first JoJo remaster, All-Star Battle R. So the fact that we're now getting a remaster is huge. What a start to the day. I mean, I say start to the day. It's like 5 o'clock. Like I woke up at like fucking 3 o'clock. So that's oh my days. Okay. Let me. It's just a leak, so there's nothing too big. Like, actually, okay, I should check. We could get our first JoJo Lands character. That'd be so sick. And like, it wouldn't really be spoilers because nothing really happens, right? Same with Eyes of Heaven. Same with ASBR. Like with JoJo, there weren't really any spoilers. There were for definitely for Steelable Run though. Like they fucking released Alternate Diego. So I wonder if they will remove. I wonder if they'll remove Alternate Diego until the end of the anime. They should do, because like that is a really cool moment in the story. I mean, sorry, spoiler alert for anyone who doesn't watch, but like for who hasn't read, but like yeah, it's so cool. Teranosuke. I do hope, because like Eyes of Heaven is an arena fighter, okay? So it's different from All-Star Battle, which is like a more traditional fighting game. So they could definitely add more esoteric characters, you know, like characters like are a bit more unusual in terms of their movesets. Like Tonio is my favorite character. He's my profile picture. He's a chef, right? So that's kind of hard to implement into a fighting game, but for a different game, it could be something. Hold on. This guy's the same PFP as someone else I know. Is it the 40th anniversary already? So, assuming the story mode is intact, we should get a redubbing of everything from the anime voice actors, which would be really good because like there's a ton of voice lines there, which would be a gold mine for like edits and stuff. Sign up for Cock and Ball Torture. That's right. Golden Spirit is the other game. This is too cool. Oh my days, we are so back. Okay, back to this video. Sorry.
In this case, exactly the same thing would represent the very end of the memory that you have. To happen in this case is something called a deep copy.
Right, so a deep copy. Dude.
We want to have an exact replica of V1.
Okay, so definition. Deep copy.
And this is absolutely reasonable because this makes our code easy to understand, easy to comprehend. Take a look at this, we know that afterwards we do not have to take care of any kind of sharing. So,
deep copy. Yeah. So creates a completely independent clone. So what's a telecopy? The top level structure, but not the things inside. Okay. Differs from a shallow copy, which still stores references to more complex data structures within a struct. Yeah. Okay. Yeah. So like this is what I'm kind of saying. Like in Rust, the move is implicit, right? Like you have like a let mutable v1 and then like v1 equals v2, and I believe that moves it. But like, maybe it's just because I'm used to copying, but copying just feels like right. Then again, equal sign generally means equality, right? So if I say that v2 equals v1, then v1 should equal v2. Except that's not the case here, because I don't know. So I feel like when it comes to implicit moves, which Rust does, implicit moves, that's its default thing. They should. I really think that they should have changed the assignment operator to be like an arrow, like an arrow like this. You know, that's really small, but a left pointing arrow instead of an equal sign, because an equal sign looks like you are copying it. But again, maybe it's just because I'm used to it, but I do feel that.
So we want to have a real copy, a deep copy. That's by the way called value semantics.
Okay.
Let's do another example. Let's say we have a function create vector that is returning a vector.
Yes.
And again, I have an empty vector v2.
So this will copy.
v2 again is just an empty vector, zeroed out pointers inside. Let's assume we directly assign create vector to v. Now the first thing that happens is that of course I return a vector from the function.
Yes.
That function is, well, that value is something I don't really have a name for. I call it temp. And it is created by something that we can ignore now, the return value optimization. Now it's somewhere in the calling scope of this function call. Now this one is assigned to v2. But do we really want to create a deep copy at this point? Oh, this would be a shame. Because of course, if you do a deep copy, temp will be destroyed at the end of the statement.
Yeah.
We have wasted a lot of energy.
Yeah.
That is not what we want to do.
No.
What we really want to do is actually, we would like to transfer the content of temp to v2 in a very simple way.
Okay, I'm gonna go get breakfast real quick. Like bring it here, but. Ooh. Some good Weetabix. Weetabix, one of the few cereals that isn't absolutely shit for you. Man, I can't believe. Ah, Ice of Heaven, dude. Oh my days. Right.
We simply want to, well, first of all, copy the pointers. That's the first step. We cannot stop there, however, because at this point there would be two vectors owning the same memory. They do not know about each other, and deleting the memory then, of course, wreaks havoc. Now, the second step is we have to remove the pointers of the first one, and for instance, just set the pointers of the first, so this temp vector to zeros. That's great, because this is very cheap. This is so cheap that we do not really think about.
If you standard move a trivial type like a uint32, right? What happens then? Nothing, right? Like I guess you just cast and then like fucking nothing happens because like what are you moving? I guess.
It as an operation itself. So the idea is do the minimum amount of work to transfer temp into v2. And of course at the end of the statement, okay, by the way, note this is only possible, this kind of optimization, because nobody knows about this temp except for this assignment operation. Mm-hmm. No one else holds a reference to temp. If there would be somebody else holding reference, then we would have a problem. All right, at the end of the statement, however, temp of course goes out of scope. And now the final result, the vector we created is in v2. Perfect. Now you already start to like it. Hey, this is cool. So why don't we apply this to the first example? Well, of course, in this case, we would have a problem. In the
he didn't use a standard move here. So does it just happen implicitly? Oh yeah, it must do. Oh right, because this is an R value, right? Okay.
Cool. So
Makes
why
sense.
don't we apply this to the first example? Well, of course, in this case, we would have a problem. In the code, we would not see that v1 is transferred to v2. And this is the kind of the wrong semantics. But we can do something about this. If indeed you're interested to transfer the content of v2 into v2, v1 into v2, then all we need to do is to use move. Std move is now basically telling us this is a transfer of content. So we'll take a look at the details later, but at this point, we basically proclaim we want to transfer from v1 to v2. And we do exactly the same as before. We first of all copy the pointers, and the second step is again, we just delete the pointers, not delete, we set them to 0 in v1.
Yeah.
v1, however, in this case,
Change that default state.
lives on a little longer. So, but this is the details that you take a look at later. Right now, just remember v1 is still alive. It will be.
So, I wonder if the compiler, I mean, it depends on the compiler, but like, let's say like Clang or GCC, I wonder if they'll tell you if you try to use something after move. Like, you should like use after free. I don't know if that's even warned in those compilers. Rust, because of the board checker, it will tell you.
An empty vector for quite some time, well, until the end of some scope. All right, let's take a look at the details. On the left-hand side, again, we now see the vector. Standard vector, a small excerpt from standard vector. And on the right, we see the example that we saw before. The first statement that we analyzed was this one. v2 is equal to v1. Now this is, v1 is now something called an L value. Oh my, now he's starting with technical terms. Okay, let's clarify the technical terms first.
Okay.
Just a little bit, there's more back to basics talks that go much into more detail here. L value. And there's also something called an R value. This is what people usually are a little confused about. So there's a historic reason why they're called L and R value. The L in this assignment, that is an L value, simply because it appears on the left of the assignment. And the other thing, the R, that is an R value, because it appears on the right. R value. This is what people usually a little confused about. So there's a historic.
Okay. So. Historically. The fuck. Historically, the terms L value and R value come from how in a simple assignment the L value is on the left and the R value is on the right. Yeah, simple L equals R.
Reason why they're called L and R value. The L in this assignment, that is an L value, simply because it appears on the left of the assignment. An L value could theoretically also be on the right side, but well, an L value can be on the left side, so it has a certain name. This is, however, only the historical thing. This is where the name comes from. Do not really remember this from a C++ point of view.
However, it is but a historic, however, they are but names. It is not so good to remember them as this.
Unfortunately, it does not work well anymore. I'll give you a simple example. Let's say we have a string, then s plus s is equal to s is actually valid code. It will compile, will not do something reasonable, but it is valid code. And it is kind of reversed, because now the s on the right is an L value. And on the left, actually, we have an R value. So it's kind of reversed. It's pretty unnatural, it's pretty surprising again. But there's a much better rule for C++, something that you can remember and that works absolutely fast.
What does this do? What does this do?
Fascinatingly well. The thing on the right, the S is an L value because it has a name. A name that you have chosen, an identifier that you have deliberately created.
A better way to think about them is an L value has a name / identifier.
Was chosen for this variable. An L value. Now on the left, however, you have an R value because it does not have a name.
An R value is nameless. Like the result of an operation. Like the immediate result.
So the result of s plus s, this temporary, you did not choose a name for, and hence it is an R value. That's the entire difference between L and R value. Now, V1.
Okay. So eventually, no. or windy rather. So an R value, sorry, an L value is something that can be referenced then, right? And an R value is something that is temporary. So really it should be called a T value and an R value. T for temporary, R for reference.
One has a name,
Abo.
hence it is an L value. And L values, well, okay, they bind to the assignment operator that you see here on the left. That is
Bind.
perfectly okay. This assignment operator now would do a copy, because it assumes that you indeed want to have this copy.
Right, but that's because const reference is not a const reference. It's actually evil.
Bind to the assignment operator that you see here on the left.
Yeah, it's so annoying how that's a thing, bro. Oy. Just another reason why C++ is doomed.
That is perfectly okay. This assignment operator now would do a copy, because it assumes that you indeed want to have this copy. Everything's fine.
Because it's an R value, yeah.
Now let's go to the second assignment. Create vectors. V2 is equal to create vector. Prior to C++11, this would actually have created a copy. So it is an R value. We said this before. Prior to C++11, this would actually have created a copy, because there's only one assignment operator for that case. And that is, I have to say, was the essential problem. I could not distinguish between the first case and the second case. The first case, the L value, is copied. The second case, well, I want to deal with this differently, but unfortunately...
Sorry, no, this is not an R value. This is an R value. This is an L value. Hold on. Other names for L value. Locator value. Okay. Despite their misleading names, L value and R value are still used. Are there any other names for them that are more accurate and therefore better to use, that are popular? No. Fuck! Guys, can we please change it? Location read value. Okay. Yeah, even more cryptic. Fucking X value, bro. Expression value. So L value is something with location memory, which therefore it can be referenced. R value, a value you just read. Yeah, so L values is adjustable, R values are temporary. And is IE is adjustable. Okay. Locate and read. Ah, that's right, I guess.
As long as there's only one assignment operator, it would also do a copy. For that reason, they introduced what you probably have seen before, R-value references. So, using two ampersands for a reference makes it a so-called R-value reference.
Kill me.
An R-value reference does exactly what you would expect. This R-value reference takes R-values. So R-values bind to R-value references, L-values
Temp values.
L-value references. So
A values.
with R-value references in play, the other kind of reference is just called R-value reference.
So there should be A values and
now
T
with
values.
R-value reference, you have actually something to make a difference. So the R-value can now bind to the R-value reference.
Yeah.
And this function knows about the fact that it is an R-value.
Yeah.
This function now can assume that you want this to be transferred.
Yeah.
Well, it's a temporary anyway. A temporary that is not needed afterwards. And as I said before, there's exactly one reference to this kind of vector, so this particular temporary. So I can do a move. So this operator, the one that takes an R-value reference, moves.
Right.
All right.
So that's decided
let's
by the
take a look
compiler,
at the third one.
not by like you
V1 is...
explicitly moving it.
Okay, question to you. What kind of value?
L value.
an L value. It has a name.
That casts to an R value.
However, the move operation now makes it an R value. I basically declare it makes it an R value. It has a name. However,
So I hate when that happens, bro. I don't want to call an emoji. Stop it. Standard move essentially just casts X, casts an L value X to an R value.
the move operation now makes it an R value. I basically declare, please treat this V1 as if it would be an R value. Officially, not to confuse you, but officially this is called an X value. One more term, expiring value.
Okay, to an X value. Expiring value.
It's basically just for the C++ guys to have some vocabulary to deal with this explicitly, but basically make V1 now some kind of R value. And because we deal with this as an R value, it will bind to the R value reference.
He's explaining X value versus R value.
Exactly where we want it to be. So it will be treated as an R value, and I move the content of V1 into V2. Now V1 is, well, still alive. It lives on.
Okay, so he's explaining it. So value categories, let's look at this again with my newfound understanding. So a pure value, R value, a pure value. God damn it, dude, I hate this. Right, so a pure value is an expression whose evaluation computes the value of an operand with built-in operator, or initializes an object. So it may be a variable, a new expression, okay. An X value is a GL value that denotes an object whose resources can be reused. An R value is either of these two, which means a GL value is also an R value. Generalized L value, an expression whose evaluation determines the identity of an object or function. Man, I still don't understand that. So L value, okay, so the name of a variable, yeah, a function, data member, okay. A function call or overloaded operator expression, whose return type is L value reference. I guess that's kind of obvious, right? Yeah, so A is an L value, is. Yeah, so here, although it's on the right, it is actually a left value. Isn't that awesome? A ref equals 5. It returns a reference to A. Oh. Yeah, I didn't realize that was actually valid. But I guess why not? It's just a bit kooky, isn't it? Trying to think, would I ever use this? Probably not, but like, interesting. A equals B, A plus equals B are all yep. Plus will say yep. T reference. Okay. A string literal. What? Ooh, okay, that's interesting. So a string literal is an L value because it's addressable, right? fuck? Control C. CPP reference, there's no date here, but there is a URL. I could do like a date access, I guess. What's today? The 3rd. Whoops. It's the 3rd of June, 2026. So so a string literal is actually an L value since it is addressable. Okay. The training condition for B and C, where both are L values of the same type. A string literal such as hello world. A cast expression to L value reference such as Zettelkasten x or Zettelkasten void int x. Okay. You can Zettelkasten a reference. Okay. Just trying to think when I would use this. If I were to like narrow it, maybe. Right? Like say I have. Well, actually, let me do a test right now. Say I have. A standard UN64T A equals -1 okay, and then return A. $255. What? That's weird. Why is it 255? Let's just see out. Right, so we get this massive number, right? Now, if I have a standard uint 32T reference B, which equals A, that's valid, right? Non-constant L value reference to type cannot bind to value of unrelated type. Right. So this is invalid. If I do 64, it'd be fine. So now if I said like, okay, let's say B equals 5, then now the whole thing is 5, right? And I'll also format it. So standard formats, we'll print it as bytes, so 08x should cover it, I think. 8 bytes. Yeah, that's correct, I think. and we'll feed it a. No member name format and namespace. Oh, for fuck's sake. Okay. Standard equals C++ 23. Why? Okay, now it's showing it. Don't know why the compilation is so slow. I guess that's why. Okay, so we get 50000000005. What? That's weird. Oh no, that's correct. For a new line, that's why. So it's little endian. No, big endian. Interestingly enough. Yeah, so we have our bytes here. 1, 2, 3, 4, 5, 6, 7, 8, right? So that's 5. If I were to remove this, I should get like FFFFF. Just F's everywhere. Exactly. How many bytes? 1, 2, 3, 4, 5, 6, 7, 8. That's a uint 32. No, 16 bytes. My bad. Let's give it a second. Okay, so now if I add this back. Yeah. So now, if I make this a 32, it will not allow it. But if I do a static cast to a standard uint 32t address thingy, this should give me the low bytes. Non-cost value reference to type 32, cannot bind to a value of unlimited type 64. Huh. So it's telling me that I can't static cast to this. So if I can't static cast to it, when would I ever do this? That's really weird. How about dynamic cast? Yeah, I'm just throwing shit at the wall, but. No, okay. What about with the C-style cast, actually? So for some reason it works with a C-style cast, but not another one. Okay, I guess just like for safety. But I can bypass it, and now you see that I set B, which is only the low bytes, to 5. So okay. Yeah. Anyway. Same as GL value. So a PR value, a pure R value. A literal that isn't a string literal, like 42, true or null pointer. A function called to return type as a non-reference. So what's a pure? Yeah, I don't understand that. See, the examples help. Yeah, obviously because these just return true, false, and all that kind of stuff. The built-in address of expression. Yeah, because it returns a pointer. Okay, same as an R value cannot be polymorphic. So then you have X value. I assume an X value is not a PR value. A.m. Standard move. So an X value, which is, what's it again? Expiring value, is when M is returned from an R value function, or like member. Okay. Then GL value is either an L value or an X value. Sick. And R value is either a PR value or an X value. So an R value cannot be taken by the address of operator. So to prove this, I should be able to do standard cout the address of a raw string literal. Let's say hello world. Holy shit, it works. And to prove it even further, if the compiler is smart, it should use the same address for this. It does. Hold on, let me just make this clear. Notice these are different statements as well. Yeah, it uses the same. But now if I were to modify this to be /n, would it be different? Yes! Is that okay? Look, it's different. Oh, that's cool. That's sick. A ning. So okay. Therefore, this actually works. Bro, it'd be so cool if people taught strings in this way. And the output of both would actually be the same, since a compiler should be smart and reuse identical string literals, static strings. Furthermore, or like likewise, changing one of the strings will change, output will lead to different addresses being output. So cool, bro. How did I not know this? Like, I feel like it's such a important detail, like to understand how strings work and stuff. That's so cool. I'm in love. Okay. I wonder if I were just doing optimizations, I wonder if that would make a difference, but string literals are L values. and identical strings have the same address since they are the same value. Since it'd be a waste to copy them. So I wonder then, can I force a copy? Can I force one of them to be a copy? Because even if I like do some const char a equals hello world, and then some const char b equals hello world, I assume these would be the same, right? So first let me do this, and then let me standard C out a, and then b. The address of. Yeah, that is kind of annoying actually. I don't know if this will even work. It'll give me the address of both. No. Oh, it's just compiling. But why so slow? Yeah, so that's because I'm getting the address of these. What I need is the address of the string, which would be a standard. I need to cast it to a value. Yeah. Whoops. Wrong thing. Yeah, so these are identical. These strings are identical, obviously. Now, if I were to set this to hello world, would it still be the same? Yes, of course. Because it is an L value. And likewise, if I were to do this, and then also print the address of hello world, but as a thingy, yeah, they're all the same. Sick. In fact, I can make this a bit simpler. If I just dereference and then get the address of that, that should give me the same, right? That's so funky. It treats a const char pointer as just like a thing. It's a string. Man, just strings are just so hard to wrap your head around because of like how they're like handled. But anyway, copy that. Sick. Like, look at that. That's crazy. Anyway. Let me drop that into Obsidian real quick. These are also all identical. Suey. Right, back to the fucking talk. Sorry.
We have transferred the content from v1 into v2. Great, this is what we wanted. But v1 lives on. It has a name. You can still use it afterwards. And this makes it, to some extent, a little dangerous.
Yeah.
So, officially the standard says this is a moved from object. A moved from basically says, don't use it, and to some extent, a little dangerous. So, officially the standard says this is a moved from object.
Huh?
So, officially the standard says this is a moved from object.
Officially, the standard says this is moved from object.
A moved from basically says, don't use it anymore. Yeah, okay.
C++ please moved from object. Moved from.
Okay, if you know a little more, perhaps you have some ideas how.
Which is a type of rvalue. Really, rather than moving x itself, it just tells the compiler that x can be moved from.
To misuse it, of course, but the general advice would be just leave it be. Just wait until it naturally dies, so at the end of its scope it will be properly destroyed via its destructor, but don't do anything special with it anymore. Officially, there's only 3 operations that you're allowed to use on a move from object. The first one happens implicitly, that is the destructor. The destructor, of course, will eventually be called. And then there's 2 other operations that you can do deliberately. The first one is a copy assignment, and a second one is a move assignment. So you can assign to this thing again, and suddenly it becomes a valid object again. You can.
So that's what we have, like what's it called, like the 4 something, or like the 7 whatever, where for every class or like struct, you give it a copy constructor, move constructor, fucking operator overloads of the equal sign for copies and things and moves and so on and so forth.
You can again use it, you can work with this properly. But
I do use this myself actually. I should have something in GitHub. My library in my here for the binary classes, I do believe I make use of these. Yeah, so you have the default constructor, you have the copy constructor, this is the move constructor, this is the assignment copy constructor, this is the assignment move instructor and constructor, fucking hell, and then you have the destructor. So 1, 2, 3, 4, 5, 6. 6 if you include these 2, I guess. Right? But yeah, like these are the 4 musketeers, you could say. There is more, I think, but I can't remember what they are. Yeah. Truly something. So copying is just default. For moving, yeah, I move the storage inside. And move this as well. No, I don't move this. I move the other storage, I don't move that. But that's if it's okay, so now I understand what this actually means. It means that if this is a decaying value, a temporary value. So when we move it doesn't really matter that. And then this is just copied because it's trivial. It's a uint32, I think, or I think a size t, which is fine. But storage is a vector. So hey, okay, and I understand that now.
But as long as you did not reassign it, just leave it. The interesting question now would be, what does move do? How does move look like? And you might be surprised to find that move is actually pretty simple. This is move.
Yeah.
A move is essentially a static cast. Okay, so static cast to blah 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 ref. And this is also what move returns. Blah 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 ref. So a move returns an rvalue reference. It does not really move anything. The only thing it does is it makes whatever you give it to an R-value reference, and henceforth it's treated as an R-value, and therefore it binds to, for instance, the this move constructor, or move assignment operator. So move does not really move anything. The usual question is, does the compiler give me any warnings when I try to use something that is moved from? No, the compiler will be absolutely silent of this, about this, and there's a simple reason: static cast. A cast is, as you know, an adult feature. You know better than the compiler, and if the compiler says,
Adult
well,
feature.
you know better, then he will not warn you about any misuse later. So you are on your own here, except of course that there's other tools. So static code analysis tools might warn you about some access to or some use of a move from object. The compiler will not, thanks to static cast. All right, so now you understand that move indeed does not really move anything, but that does make a difference in terms of semantics. It is a semantic transfer of ownership. So some people actually argue that it should not be called move, but something like transfer content, transfer ownership would be a much longer name. Move is probably a little nicer. But this is the semantic.
Why would you call it transfer ownership? Like move, it can just be a synonym for transfer. Really, it should be called cast to R value, or like cast to X value. That's what it should be called if you want to get pedantic.
The part about it. It is a move from a semantic point of view, a transfer of content. It is not a physical move. Nothing physically moves anywhere.
Right. I mean, I get that, where like it's passing the ownership to something else, right? So like nothing's like moving in memory per se. It's just like pointers get copied. Yeah, I guess. So yeah, it can be quite hard to understand.
Anywhere. All right.
There's more.
A short summary in between. So containers in C++ employ value semantics. This is something that we desire. This makes our code easy to understand, easy to comprehend. We do not have to figure out where is sharing happening under the hood. In pre-C++ 11, this led, of course, to a lot of potentially expensive copy operations.
Yeah.
Thanks to the introduction to R-value references, now we are able to distinguish between L-values and R-values, and we can therefore react accordingly. We can deal with L-values differently than we can deal with R-values.
Yeah.
And R-value references basically just represent modifiable objects that you do not know, that you no longer need.
Side note, you know how these essentially do the same thing? Except this one returns something that this one doesn't, right? Is it possible to just like combine these somehow? Like, no. I don't know.
Temporaries, all things that you have explicitly declared to be temporaries, and basically explicitly said, I don't need this anymore, please transfer content, please optimize.
Please optimize, yeah.
All right, now let's take a look at some implementation details. There is two functions that you need to make this entire magic happening. And these two functions I show in an example of a widget class. So class widget has three data members. An int is a representative of a fundamental type, a string as a representative of a class type, and a unique pointer. Admittedly also a class type, but a special one. It's a pointer type, reference semantics.
Okay.
And the two functions that I mentioned is these two.
Yes.
The move constructor and the move assignment operator.
Right, so the move constructor and the move assignment operator. Oh, that's right. So you have the move constructor, the copy constructor, the move assignment operator, and the copy assignment operator.
This is the two functions that are now also added to the set of special member functions. So now in total we have 6. The default constructor.
Right, so yeah, so 6, okay.
The two copy operations, the two move operations, the new ones, and of course the destruct.
So, okay. I will make notes of this.
Added to the set of special members.
In total, a class that benefits from being movable from being even a user defined type, like a class, that benefits from being moved would have 6
member functions. So now in total
6 basic member functions. I don't know why they call them methods. Like, just more confusion, bruv. So you have the constructor. You have the copy constructor. Sorry. Default constructor. Foo empty. The copy constructor. Foo. The move constructor. It's just like const x. The move constructor foo const not even const, just boom boom x. Looks like this, makes sense. Copy assignment operator. So operator equals with a const x, and then move assignment operator. But there's a sneaky one more, the destructor. Destructor, which takes no arguments, of course.
we have 6. The default constructor, the 2 copy operations, the 2 move operations, the new ones, and of course the destructor. The canonical syntax for these two, the canonical signature of these 2 functions, is one argument of exactly the type of the function, the class, ref.
It is it. Yeah, so these both return binary references actually. Okay, so they both return lvalues.
This is indeed the canonical signature. There's not a lot of difference you can make. You can actually add a const here, but it does not really help you. The purpose is that I do modify the object that I'm given. So, well, a const doesn't help. And as soon as you leave out any reference, it would be the copy constructor or the copy assignment operator. So this is indeed the canonical signature. For this class, actually, your life is easy. You simply can define these to default, or perhaps even leave it to the compiler. You do not have to explicitly mentioning them. This is great. All of the things that all of the data members are properly movable. The int, okay, this is fundamental. The string also knows how to transfer content to some other string, and also the unique pointer is equipped with the right functions. So this is exactly what you would like to have. This is the best possible situation. There's a name for this. So there's a.
I do wonder then, why do I have this? Because again, storage is just a vector of bytes. So why do I need to like make this explicit? Standard move that. That I don't understand so much. Cause like those are the only 2 members. And you can see that copying is fine. So I wonder why that is.
The core guidelines C20 for that. If you can avoid defining default operations, do. And
that's why Winner just
core
opened
guideline
itself.
also mentions the unofficial, or perhaps even official name for this, the rule of 0. This is where you want to live. This is what you usually want to use. Your life.
The rule of 0. Okay. I've heard the rule of 6. That's it. Yeah, what the fuck? My window just opened itself. Cheeky kid. Because it's that windy. So, define the rule of 0. Avoid defining default operations if you can. So use just equals default.
This core guideline also mentions the unofficial, or perhaps even official name for this, the rule of 0. This is where you want to live. This is what you usually want to use. Your life is easy. Your life is, yeah, comfortable. Let's, for the sake of this talk, of course, let's assume that I have to do something extra. So let's assume, for instance, that the unique pointer is just a raw pointer. And suddenly our life gets much, much more complicated. Because now we actually have to deal with these two functions. We can no longer make them default. We have to implement them ourselves in order to make this work properly. And let's take a look at the implementation details. First of all, of the move constructor.
It's windy.
Well, the goal of the move constructor is to transfer the content of the given object W into this object. And of course, we want to leave W, so the past object, in a valid but undefined state. So this does not sound great. Of course, undefined is always something that is a little vague. This basically means it can be any state. It must be a valid state, but we cannot predict the state that it will be in. All right, how do we achieve these goals? The first step is probably just to copy the int. Okay, no ill here, no ill effect, everything's working. Then, well, let's do this with a string too. So let's move the string. Okay, now, a couple of people, probably, as you know about this, probably fainted. Now, unfortunately, this is not what we might believe it is. In this line, we actually do not move the string. What do we do with the string?
It's been copied.
We copy the string. And this is exactly what we do not want to do. We want, of course, to be as efficient as possible. We would like it to move. Why doesn't it move?
Because we're not calling send and move. I don't know. I mean, we're passing an L value into the constructor, so
Knows.
that's my assumption.
Correct. The string has a name, but also the W has a name. So the widget that I'm passing has a name. And because of that, it is simply an L value. And an L value is something that I cannot or should not move. Of course, an L value, since it has a name, is still needed. Hence, I do a copy. However, there's of course an easy workaround. Okay, I should perhaps point out this mystery here. So yes, it is an L value. The type, however, of course, suggests differently. Widget ref. This is, I admit, a little confusing. Reference to an R value reference, and then it still is an L value.
Is this wrong? I don't think W is an L value, is it? I'm gonna challenge the guy who has more experience than I do. L value, X value. Where is it? Where is it? Type. Fuck it. L value CPP reference. Okay. Value categories. That's what it's called. says x value. Yeah, no, it says a.m, where a is an r value, and m is a non-static data member, the rest like that, of an object type. So it's an x value. He's wrong. At least according to this website, CP reference, which says to be reliable. It says very clearly that if you have a.m, where a is an r value and m is non-static, then m is also, well, no, m is an x value. Huh? But then here it's being an L value. So maybe it isn't? Wait, what the fuck? Bro, this language sucks. And W, no, he's correct. He's correct because W is addressable, but it has the type of an R value. Man, there has to be a better way to do this, right? According to the guidelines, in the example of widget's move assignment operator, he should have added a simple check for self-reference. Eviction operator.
It may be confusing, but it's easy to explain if you think about it like this. It is indeed an R value in the calling scope. At the point where we call this function, it is an R value, else we would not end up in this function. However, inside the function, it needs to be an L value again. If we wouldn't have a name, we could not use it. And so, well, it has to be an L value again. But we can easily make this work again by using move. We explicitly move the string to the other string. This is perfectly fine because we know, thanks to the type, that it actually is an R value. So ultimately, this is now moving the string properly. Now I apply the same operation now also to the int. No, it does not make any difference. The int is still just copied. There's no speed up at all. However, it is a nice and a pretty reasonable convention. Just move all your data members, regardless of whether it's ints, so fundamental types, or class types. Then it's, first of all, very heterogeneous, and
Client tidy says not to do this.
second of all, in case, you might see this in the remainder of this talk, in case you change the type of this I, you not have to go back here and basically fix the code. It will always work. It will never do the wrong thing. And so this is why I acquire this convention now for the remainder of the talk. All right.
Why does client tidy say to not standard move trivially copyable types? So the code is identical, but there are two downsides. Pessimizes copy elision. Okay, what the fuck? The compiler can elide copies to entirely many situations, but an explicit move opts you out of the optimization. What do you mean elide copies? Inhibits implicit move. So what? NRVO, RVO, C++. Return value optimization is a compiler optimization. In some cases, it allows not to get a local object that is used as a return value. Instead, the return object is constructed in place of the function call. This eliminates the necessary move copy. Oh, right, okay. Yeah, so it just doesn't call it. But if I use standard move, then it will forcefully call the function. Okay. So RVO, return value optimization. And how is it supposed to move? In return statements, the compiler already tries to move automatically. Writing how to move there can actually prevent the optimization. Misleads readers. It implies a type has a meaningful move semantics when it doesn't. Suppose. What about in constructors? I'm watching this CppCon talk, and he actually prefers to use standard move on everything in a constructor anyway, in case the type of a member variable is changed later. Okay. But interesting.
And of course, I also move the pointer. It's not really moved, it's also just copied. There's nothing I can do better than copying it. But as I said, I now use this convention. We're not quite done yet. I copied the pointer essentially, but unfortunately, at this point, we have two objects that point to the same number. And the basic assumption of this widget is that this pointer is an owning pointer. So now I would have two destructors that would destroy the same content, and this is bad. So there's an absolutely necessary further line. We have to explicitly set the pointer of the W widget to null. Without this, it would break pretty bad.
Unless they are the same, yeah.
Now you might think,
I do wonder, is there something in the standard library that just says like that isn't null pointer but is instead like just some random address? I don't know.
okay, so by the way, we have now, first of all, resolved our first goal. We have now
'Cause either way it's
effectively
UB.
transferred the content of W into this. Now we're there. The entire content of the right-hand side object is now in this. Perfect. Now let's take a look at a couple of more details.
Because like, is it true that null pointer can actually be a valid address on some systems? Right. Yeah, this is really interesting. Because like, I was talking earlier about this on Discord. A null pointer is nullable. Or sorry, a pointer is nullable because a null pointer. Because like, let's say I have an optional type. I wanted to have an optional reference, but for some reason you can't have optional references yet in C++. It's going to come later in like 29 or something. But you can have optional pointers instead. But then the argument is that there's no reason to have an optional pointer because you can just have a null pointer instead. But that means that if we just say null pointer is the null value, then it means that your library that uses null pointers won't work on embedded systems. Now, to be fair, people who work on embedded systems probably have their own problems to deal with anyway, and probably can't use libraries, but yeah, it's weird. Does the standard library acknowledge this and thus avoid using null pointer to represent null state? Or do embedded system developers just not use the standard library? I see they do. Both shit. Right, so internally, optional actually is a null pointer. For T-pointer specializations. Ah, interesting. So if I were to use a standard optional pointer, then it would just do that anyway. Okay, well shit. Because like I was thinking of using a standard optional pointer, but if it's the same thing inside, then it's just semantic, I guess. No heap, no exceptions, no IO stream. Fair enough. To be fair, yeah, you could just like skip that first like 4 bytes or 8 bytes and then just like sacrifice it. Interesting, volatile, okay. I've never worked with embedded systems, but it does sound interesting. Hopefully one day.
So first of all, you might feel that these two operations, well, you always have to think about this. You always have to remember that
So laggy.
pointers are special, that the other pointer, in case it's zoning, has to be set to null. There is a little helper
I'm gonna
that
close
is
this board.
called std_exchange. std_exchange is a function that sets the given pointer, so WPI, to null pointer, and it returns the old value of WPI.
Oh! Okay, we've got a new feature. So there's standard exchange. That's cool. The members of an R value are values. Right, so this is a cool comment. Standard move w dot I will actually give you an R value as well. Another reason to avoid row pointers. Yeah, the language is definitely wrong. Okay.
std_exchange is a function that
We in the same section? No. We moved a while ago. In fact, I'm in the wrong fucking note. Standard exchange.
that sets the given pointer, so WPI, to null pointer, and it returns the old value of WPI.
Okay. Standard exchange can be used as an equivalent to so let's say I have like a widget. Okay, I'll do foo. Save a foo reference f with I. Yeah, so some pointer would be standard exchange. W dot pointer with null pointer. So that's what that does. But if I didn't have it, it'd be like this. Of course, if pointer does not equal foo dot pointer, then pointer f dot pointer and f dot pointer equals null pointer. Is that correct?
Students pointers are
Oh, or just put it here. Okay. Yeah.
special. That the other pointer, a given pointer, so WPI to null pointer, and it returns the old value of WPI.
Okay.
That is, of course, the value that I want to have in my own pointer.
Okay.
That is a nice helper that basically makes this a little more compact, and you might not forget this. Although it's nice, just for educational purposes, I now simply return to the old thing. I want to show a couple of more details. All right.
Huh?
Although it's nice, just for educational purposes, I
Okay.
now make move operations no except. So let's do this, but let's also ask.
What are these core guidelines anyway? C++ core guidelines. Is this one that's on GitHub? That's profiles. Here. These are up to date, right? Two months ago, yeah. I should definitely read this at some point. I've been meaning to, I just haven't gotten around to it yet. Why am I lagging so much, dude? Is it my browser? Okay, hold on. My laptop's lagging quite a bit. How do I view which processes are the most memory intensive on Arch? Htop, eh? What? I don't have htop. Just processes. Vivaldi, Claude, OBS. Alright, yeah, I'm streaming OBS. I literally forgot about that. But even so, like, damn. Okay. So Vivaldi, let me close some tabs here. I need to finish this interview at some point. Maybe I'll watch after this video. What's this? Crafting interpreters. Don't need these. This can be useful. I'll just hibernate these. Misclick. Oh well. Could be worse, I guess. Right,
Makes
where was
this
I?
a little more compact, and you might not forget this. Although it's nice, just for educational purposes, I now simply return to the old thing. I want to show a couple of more details. All right. There is another core guideline. Make move operations no
Ooh.
except.
I think it's hot. Hold on. Let me give it some leverage. I'll use Mein Kampf to heat my computer to heat sink my computer. I actually need to read this at some point as well. Actually, it's got highlights inside. Look at that. That's a library book. How evil. Anyway.
I now simply return to the old thing. I want to show a couple of more details. All right. There.
So C++ core guidelines. State that move operations should be marked no except.
There is another core guideline. Make move operations no except.
C66.
So let's do this. But let's also ask, why is this necessary? Why is this something that is not like consider moving it no except, but make it no except? So first of all, it's actually not wrong. Moving the I is, well, no-brainer. This can never fail. This will never throw an exception. And also the pointer is a no-brainer. It will never fail. The string, well, we just have to look it up and find that the move operation for the string is no except 2. And so this is not a lie. This is perfect. This is no except. Yeah, also, of course, setting the pointer to null. But there is a good reason that the core guidelines point this out.
Okay.
It has to do with performance. And in order to demonstrate this, I've now written a little example program. So, first of all, let's say that I create a long string, longer than necessary, so long enough that this is not using the small string optimization. Then I have a vector of widgets. At this point, it is empty. N is the number of widgets I want to create. The next, I'm running a for loop, and I'm creating n widgets. And I'm pushing them back into the vector by means of move. And then, of course, I measure the time this takes, and eventually I just print the runtime.
Pushing back via move. Does mplaceback do the same thing, by the way? Does mplaceback move? I think it does, but
If I do not
that's
make
why it's
my
more
copy
performant
constructor no except,
sometimes.
then both Clang and GCC, they show exactly the same result. Solve this in 0.005 seconds.
Ah,
Just a number at this point.
it's too slow.
However, if I use no except, then suddenly the runtime goes down by 60% to only a 0.002 seconds.
Okay.
And it's quite a bit. That is not just a 1% or 2% difference. This is a very significant change. The reason has to do with, indeed, exceptions. Pushback gives you a guarantee. It gives you the so-called strong exception safety guarantee. If any exception is thrown in pushback, it is as if nothing has happened. It is as if you would not have called the function. This is a very strong and a very valuable guarantee. But as soon as we use move, as soon as objects are transferred, I am changing my inner content. And this is why pushback has to be pretty defensive. If you promise to not throw in your move operation, then pushback will indeed move. It cannot fail, it will not destroy the old state, everything's fine. But if you do not give this promise, unfortunately it has to do a cop. And so if you do not use no except.
Interesting. So without the promise of no except, the compiler will instead copy to be safe.
It basically falls back to the pre-C++11 behavior, which is pretty unfortunate, but this is why the core guideline is pretty clear. Make your operation know it.
And they see C++ isn't a safe language. Pre-C++11 behavior.
Except. All right, so let's do this. Then, what about this WI? I have set the other pointer to null, but I did not really set WI to 0 or some other default. There's yet another core guideline, 64. A move operation should move and leave its source in a valid state. This core guideline has a note. We don't read all of it. It's this first part that's interesting. Ideally, that moved from should be the default value of the type. Ensure that unless there is an exceptionally good reason not to. So if you read this, then this basically means that we actually want to set this to 0. Okay, so let's do this. However, this is not what the default would do. So if I indeed would have a unique pointer, if I would choose the default implementation, the default would not set this to 0. So if the default is not doing it, apparently it's not such a bad thing. Of course, by setting this to 0, we have now also perfectly achieved our second goal. W is now invalid, but undefined state. Actually, it is in a default state, which is what the core guideline suggests.
Okay.
But if you... Okay, so exceptionally good reason. It's the 64.
It's interesting. So after the core guidelines, the CCG, is there like a short name for this thing? C++ core guidelines. ISO CPP. C++ CCP. Yeah. Not really. Okay. The core guidelines also state that what the fuck? There, just go and state. How did I mess up so bad? Also state that after a move operation, the value that has been moved should ideally be reset to a valid to its default state.
A move operation should move and leave its source in a valid state. This core guideline has a note. We don't read all of it. It's this first part that's interesting. Ideally, that move from should be the default value of the type. Ensure that unless there is an exceptionally good reason not to. So if you read this, then this basically means that we actually want to set this to 0. Okay, so let's do this. However, this is not what the default would do. So if I indeed would have a unique pointer, if I would choose the default implementation, the default would not set this to 0. So if the default is not doing it, apparently it's not such a bad thing. Of course, by setting this to 0, we have now also perfectly achieved our second goal. W is now invalid.
But if you do this, then it's slower because you have to set it to 0, and zeroing out takes time.
But undefined state, actually it is in a default state, which is what the core guideline suggests. But if we leave this operation, well, it's also in a valid state. We just did not reset the int to 0. It is just the value that it had before.
The other issue with doing that is then you are using magic numbers, and then you probably want to have like constants for like the default state of I, and then set it to like something, right? So it's kind of messy.
And this is also a perfectly valid state. However, undefined from a higher perspective, because I cannot really predict what it will be. From a performance point of view, however, it's of course reasonable.
Yeah.
Because if I don't really...
However, this does impact performance, and also throws magic values into the constructor that may not be immediately obvious. Whose intention, whose purposes.
have to set it to 0, then leaving the out is just a tiny little bit faster. So this is now kind of the canonical move constructor. This is what I would argue is what you...
But we set the null pointer for safety reasons, which I understand. Then again though, if you're using something after a move, you're kind of a dumbass. I mean, like, the borrow checker keeps it safe. And that's why the borrow checker is so cool. Because Rust can actually be faster than, in theory, than C++ in this case. Because the compiler will stop you from using after move, right? I believe. Such that you don't actually need to set this to null pointer, because there's no way that you should be like because the compiler should stop you from even accessing the pointer in the first place. So to that end, Rust could actually be more efficient. But yeah, there's no but.
You would have to write, if you indeed have to write it yourself.
Okay, sorry, no, the but is that you don't have to do it for C++ either. You don't have to set the pointers to null. But if you don't, I suppose it's a risk. I almost wonder, is it possible to have a compile time variable for a struct so that when it's being moved, that flag is set to true? And then once it's set to true, it cannot be used after that. Like if someone tries to use it after that, it will throw a compile time error. Can you do that from C++ within a class like in of itself? Or would that have runtime overhead? Because for Rust, it'd be because the compiler handles it. It's all compile time. But for C++, you can't really do that, I don't think. Now, if you look at my binary view class, you see I do this as well. I say this equals other, then I say address equals this, pos equals other pos. But notice that I actually do not set the other ones to null pointer. So, and honestly, I don't want to. However, there is an argument for not setting the other pointer to null pointer, as it has performance overhead. A language like Rust would catch use after move errors at compile time. Yeah. So I don't set this to null, and I don't want to. I think if you use something after moving it, you're the baka, you know.
All right.
I'm going to optimize for the best case scenario, assuming that you know what you're doing. If you don't know what you're doing, it's not really my responsibility as the library developer to like hinder my library's performance so that you don't make so that you, I don't know, like dereference a null pointer and then get like a fucking crash at runtime. No, I would instead prefer that the language handles that, and if it doesn't, then those who use a language need to go in knowing that, or switch to a better language like Rust.
Now, in this canonical form, you see some like two phases. Phase 1 and...
sorry, although I don't set these to null, you will notice I still have this. This is not equal other. That's because... Well, I suppose this is actually a bit of a... Yeah, this is just unnecessary, really. It just says that if you try to assign the same binary view to the same thing, then this doesn't happen. Right? So that's like one instruction. But like, would there be a jump? I suppose it would be. I do wonder, is it more optimal to have this if or to not have this if? Let me ask Claude. I'm wondering, is it more performant to keep this if or to just leave it, since it doesn't actually protect anything, just prevents unnecessary code from being run, yet at the same time the if itself can be seen as unnecessary, since is mildly pessimistic. Yeah. So drop it. Exactly. Or default it. Even better. Like, why am I even doing this? So that's one thing to do. And then here, also, why do I need to explicitly standard move the vector storage here? Can I not also just equals default? Because like surely a vector has move semantics, right? Other is an L value, even though it was passed as an R value reference. Named divisor is L values, okay. Without this thing, you invoke vector's copy assignment instead of move assignment. But I can. Yeah, so like, why am I even defining these in the first place? God damn, bruh. In what scenarios can I not just rely on the default? So it's a null pointer. Alright, I deleted thingy. Okay. Also, for that first point, should I actually null out pointers when moving? I know the C++ guidelines say so, as well as making other values default values, as well as resetting other values to their defaults. But is this not? But does this not impact performance? Can I not just assume that the user knows what they are doing by programming in C++? Like, don't languages like Rust catch issues such as use after move? Compile time, yeah. If you don't null it when the moved from object is out of scope, it's destructible to delete the pointer with the new owner it's still using. It's a double free. I see. Okay. Does this only apply to Does this only apply to new heap allocation? So I should use a pointer. Well, I am though, aren't I? Hold on. Back to my library. So class binary, that's fine. For binary view, I'm not zeroing these out. Say address equals other than address. But the address in particular is stored as a raw pointer. So I guess I should reset this then. Or just wrap this in a fucking standard pointer. So for this example, if address is a raw standard byte pointer, I should make other.address equal null pointer. Yes. Oh, okay, so it doesn't own it, so it's fine. How do I know? What's the way to tell if a class owns its data or not? An object, whatever. Yeah, that's what I said. New malloc opens a handle. Okay. So it's fine. Okay, so let me actually make these changes right now, using what I've just learned. So I'm gonna cd projects binaries MP library, open it in NeoVim, go to my main header here. We'll start with the binary one. This should be handled automatically, so we can just say equals default, and this too equals default. I don't know if I need to mark it as no accept, but yeah, no accept is correct. Okay. Then likewise down here for binary view, this can also just be default, and so can this. I mean, like, do I even need to explicitly? I mean, I guess it helps, doesn't it? And then we have more constructors. But these are the other main ones. Okay. So const reference. Okay. So let's see if this compiles. Compiles. I haven't actually looked at the test in a while. What even happens? Nothing. Okay, sick. Just leave it then. So git add, git commit. Just use default constructors, since there are no special move overloads. In the case that all 6 of my constructors as destructors are just equals default, do I even still include them? Okay, so yeah, so the rule of 0. So I want to explicitly just emphasize that, yo, I got the rule of 0. So all of that is necessary. Do I still keep well, no, because the members are private. Yes, so just have no, just have nothing. Like, because they're private, I believe they can't be constructed anyway, as if they were a struct. So that should be fine. Let's see. Looks good. And then I'll run clang tidy afterwards. Nothing wrong. Okay. Git add all, git commit, remove default constructors / destructor since they're all to emphasize the rule of 0. Nice. Pretty cool. Okay, back to the video.
Phase 2. In phase 1, I do a member-wise move. All the members are explicitly moved from W into this.
Right, so he didn't specify
in phase
that.
2, I'm explicitly dealing with pointers. Pointers are unfortunately special. Pointers have to be handled explicitly, so I have to say owning pointers. If it's not an owning pointer, you probably don't care.
Okay, so he did say it.
Any pointer is special, I have to deal with this explicitly. So please don't forget this. This is a usual kind of problem.
Or just wrap it in a standard unique pointer, and then it's all done for you, right?
If
Awesome.
I, however, make this a unique pointer again, so going back to what we started with, then what I can omit is phase 2. By the way, now see, I changed
Yeah.
the type. I do not have...
So I'm trying to think, are there any situations where this isn't the case? Like where you can't just use a default?
have to adapt phase 1. So I moved WPI, and this is still exactly the right thing to do. Now I'm only left with phase 1. If this is what you only need, if phase 1 is all you need indeed, then you are fine with the default. The default move constructor does only do phase 1, a member-wise move. Move member 1, move member 2, move member 3, and so on. This is what the default would do. And note, the default is also no except.
It's quite amazing that C++ has been able to actually simplify something in this way.
And so you don't have to worry. The default gives you the whole package. And as I said, this is...
I mean, it does so by disallowing you from using raw pointers, but like, still.
exactly what you would like to have. This is the perfect class design following the rule of 0. All right. Now, going back to this, this form that I said is the canonical form for an implementation that you do. Of course, there's other variations. Of course, there's options you have. I cannot show you all possible implementations. I can only show you the canonical form and hope that this is what you use most of the time, if indeed you have to write this function yourself. I would follow the advice of Howard Hinnant. I think the most important takeaway is that programmers should be leery of following patterns without thought.
Good quote.
So, think about what you really need. Think about how to transfer in the most efficient way the content of the other object into this. If there is something better you can do than this canonical form, of course do it. This is all about performance. This is all about efficiency. And you can do whatever is necessary to be as fast as possible. Right. Having covered the move constructor, let's take a look at the move assignment operator. Question. So, can you use the mic? Thank you.
Go back. Can you go back to the page with the unique pointer? Yeah. So when you stood moved the PI,
Stood move.
did that automatically reset W's unique pointer or leave it alone? Because stood
Yep.
move's just a static cast.
Correct. So basically, you answered the question yourself. If this move WPI would also nicely reset the WPI to null, oh, this would be nice. A lot of people are usually asking me, wouldn't this be exactly what I want? There is the problem with non-owning pointers. A non-owning pointer perhaps should not be reset. And so there is no general move that always resets the other pointer. It depends on what you really want to do.
Like in my
case
case.
of an owning pointer, therefore, you unfortunately have to do it yourself, and you have to think about it. Else, it's usually a serious bug. No, it's not done automatically. The string is different because the string, of course, has the move operations itself. Okay, this one. Sorry, then it was misunderstanding. this one. So do I have to move the unique pointer? So this version. Yes, I have to. The unique pointer, again, it would be an L value. I would copy the unique pointer. Okay, now I got the question completely. Yes, the unique pointer is completely reset. Absolutely. That is part of the class. Okay, sorry for the misunderstanding. Yeah, so the unique pointer as a class type knows exactly what to do. It resets its internal pointer automatically. And this is exactly why phase 1 is perfectly enough.
Or it happens so often, like someone asks a question, gets completely misunderstood. They answer like just completely off, like completely on the wrong question. I mean, it happens to me so often, like in classes and lectures, even back in high school, where I was just like, thanks for explaining that thing for like 5 minutes, but it's not what I asked. So I ask again, like, oh yeah, but I meant this, and they still don't get it. And it's like, okay, instead of just like going off on a tangent for 10 minutes, could you just like stop and like try to fucking ask like what I actually mean first to make sure you understand the question? Because that's important. Good skill to have as a presenter, just so you know. No shade to this guy, but like just like in general, people in my experience have just been so bad about that. And still are in lectures. So yeah.
You don't have to. You don't have to do anything. Class types are much easier to handle than pointers. All right. Okay. All right. Then, moving forward, let's take a look at the move assignment operator. And of course, this one. Oh, question. I'm sorry.
Yes. So if you have this case where it's an owning pointer, you try to use the default move constructor? Are you gonna get a compile error? If not, what are you gonna get?
Okay. I hardly understand you. So mic is not particularly good.
Oh.
Question. I'm sorry.
Yes. So if you have this case where it's an owning pointer, you try to use the default move constructor? Are you gonna get a compile error? If not, what are you gonna get?
What?
Constructor. Are you gonna get a compile? You try to use the default move constructor. Are you gonna get a compile error? If not, what are you gonna get?
Default. So if you try to use this default move constructor, are you gonna get a compile error? In this case. Oh, I see. Okay, I see what he's asking. No, you just got undefined behavior, right?
Okay. I hardly understand you. So mic is not particularly good.
Okay, sorry.
Yep.
Yes. So if you have this case where you have an owning pointer and you use the default move constructor, are you gonna get a compile error? And if not, what are you gonna get?
So you're asking whether in the default constructor, if I get an error to do that? No.
So if you don't implement it, if you just said
so
equals.
the acoustics is just so bad. There's so much echo that. So you have to find the right distance.
Okay.
It's really hard.
If you just say equals default.
Okay. Yeah.
Are you gonna get a compile error because you have a type that's not movable?
Okay. So let me find the right slide. Now I got it. This one.
Well, but instead of the unique pointer, you had a raw pointer.
Okay. Basically, if I have a pointer now with default, do I get a compile error? No. It could be that this is perfect. If it's an unowning pointer, perhaps this is exactly what you would like to have. So unfortunately, this is not a compilation error. There is no warning. Oh, you forgot to deal with a pointer. No, unfortunately, no. There's not a lot of help here. So you have to really remember yourself. Okay, other questions while I try to find the slide again. All right. The move assignment operator. It is very, very similar to what we've seen before, the move constructor. First of all, we should think about what we want to achieve. It is a little more. We now have 3 points. The new point is the first one. We also want to clean up all visible resources in the in our own object. We want again to transfer the content of W into this and leave W in a valid but undefined state. So it is similar, but it is a little more. But this is reasonable because the assignment operator is of course changing an existing object, whereas the constructor is creating something new. The constructor is usually simpler. Now, the first step we do is, again, we move the int. Again, I use the convention to always move. Yes, again, this does not do any kind of speed up, but it is just a little more canonical. Then we also now do it correctly. We move the string. Again, if you omit the move here, we do the wrong thing. It would compile, it would work, but we would indeed do a copy, so we correctly move. And then we move the pointer. Also okay. But now in this case, I have introduced another kind of error. I have now overwritten my own pointer, my PI. Previously, there was some value in there, some value to the content I own. Now it's gone. So what you must not forget in the move assignment operator is to explicitly delete PI. Also, this is not part of the move thing. This is something that you have to deal with yourself. So usually the first line is delete. And not just the first line. If you have more resources than the beginning block is usually just what you do in the destructor as well.
Right, so if it's an opening pointer and you're moving into it, you want to get rid of the old stuff, right? Because you can't assume that we're just going to be empty. Yeah, makes sense. Yeah.
So unfortunately there is apparently some kind of duplication.
But in this case, you need to check if
so we dealt with our old resource, so we cleaned up all these resources properly. Perfect. First goal is set.
Question incoming.
Then again, afterwards, I reset the pointer of WPI to null pointer. Now, at this point, we have again effectively transferred the content of W into this. Right. Again, you can use a std exchange. It makes the code a little easier to read, and you do not tend to forget to set the pointer. If you make this the habit, exchange pointers. But again, although it's great, for educational reasons, I just show these two operations explicitly.
Okay.
Now, in these two operations now.
How about a std delete exchange that deletes and exchanges? It's that thing, actually. No.
Some people use a different form. They kind of collect these three into a swap. What you can also do is use swap, PI, and WPI. This is still, perhaps unfortunately, a common way to implement the move assignment operator.
What the
It
fuck?
is unfortunately a little less deterministic. So there's a couple of arguments that usually against this form. Yes, of course, it's very elegant, it's very short, pretty expressive, but in this case,
not
you're
elegant.
transferring your old resource into W.
How's that elegant? It's completely semantically
This is fine.
incorrect.
It will be taken care of eventually.
Doesn't make sense at all.
But what
It's not
you don't know
intuitive.
exactly is when. Eventually, at some point in the future, your resource will be destroyed. But since you cannot tell anymore how long it will still stay alive,
Who
it's
cooks here?
less deterministic. Also, if
The
you're
fact that like this
counting
is even being
operations,
discussed is
then
crazy.
just pointer operations, there's one pointer operation more. So it's a little less efficient. Yes, it's elegant, but I tend to just recommend use this form explicitly.
Okay.
All right. Again, do not.
Question, please.
Here we go.
Can you hear me? I'm not sure.
Yeah.
Sorry, very nervous. So assuming as you're cleaning up your resource before you do the move, this would all go horribly wrong if the reference you were passing in was actually a reference to the object you were swapping into.
Actually, making a game one line of code. What? What's common loop up to, bro? Yeah, so this comment here. I think is that there needs to be a simple check for self-reference.
Moving into.
Okay, I
So-
again, unfortunately, caught half of it. I'm sorry.
Sorry, I'm really very nervous. So I'm assuming.
Self-assignment.
Yeah,
All right.
self-assignment. So when you do, it would only happen if you had a stud move on an L value, I assume,
Yes.
because if it's an R value, it's a 10.
Okay, this
So-
is a very good question.
Is when you do that static cast to an R value,
Yep.
would I still be able to have a check to check that
Actually, it's an X value.
not the same as this?
It is an R
All
value.
right, so actually it is. So self-assignment, in short, a move to self. This is possible, of course. I could simply write something like W is equal to move W. This would obviously be a move to self. What would happen in this case? Well, let's think it through. Delete PI, I would delete my own resource first. All right, now it's gone. Now I simply copy my pointer into my own pointer. I move my string into S. Now, of course, this depends on what the string does. And then I move my own pointer into my own pointer and set myself to null. So essentially afterwards, I'm just kind of in a default state. Not quite, because I copy the pointer, the int, but it's like as if I moved from. Move to self is different than copy to self. If we copy to ourselves, so W is equal to W, we assume that nothing changes. The object is still in the same state. This is the basic assumption. Move to self, however, basically means we have no assumption about the outcome. What should it be? W is equal to move W. You explicitly said move W. You basically say, I don't need this guy anymore. So this is actually perfectly fine. I do not have to protect against self-assignment. Afterwards, it is moved from.
It is a good argument, actually, in the case that is self-assignment. However, what it doesn't protect against is if I just happen to have shared state. Now, if you have shared state, then it's less of a move operation. It's more of like a merge. You're merging them together. You're merging their state. So hey guys, maybe we need merge semantics next. Honestly, merge semantics would be really useful for like modding and stuff. You have no idea. Like as far as like modularity goes, merge semantics would actually be useful. But you know, it's not hard to define that yourself, so it's fine. But yeah, if you've shared state.
If you feel uncomfortable with this, of course you can add an if statement. If address of right inside is not equal to this, then do this. Also okay. The result is valid but undefined. So move to self is indeed different than copy to self. And you can feel comfortable by just making this as fast as possible. What must not happen, however, is of course a crash. A crash is of course out of the question. Okay, question.
So essentially move to self is undefined?
Okay, a little louder, sorry.
So move to self is then considered undefined behavior? Or
No, move to self is not undefined behavior. Afterwards, however, this value is in an undefined state, as usually, a move from object. A move from basic.
Yeah, UB versus US. US. I like how he makes that distinction actually. It's not undefined behavior, but it leaves it in an undefined state. So yeah, what's that make me think of? Because like yeah, if self-assignment, you know, like why are you assigning to yourself? That's just a mistake. For shared state, I'm just trying to think. Let's say A and B both share a vector, but they have different like things. Like let's say I have a. There's actually like no good example here. Let's say for some reason. No, because like this only matters if this owns its own data. So for both of them to be owning the same data, you'd want to use a standard shared pointer. So, but if you were doing it with raw pointers where you do share state, so one can be owning and then share it with another one, then you have to be careful. And that purely depends on whether your class supports it or not. So yeah.
Basically means, okay, could be in any state, I don't need it anymore, I just leave it die. By the way, W is equal to move W. This is probably the only situation where you obviously move some valid object into itself. I am only aware of one other situation where move to self happens, and this is in a swap. In a second move operation inside a swap. Swap usually 3 moves. In a second one, I move to self, but I move from object into move from object. If I indeed do move, swap.
So if you swap it with yourself, basically.
So also in this case, this is perfectly fine. You do not really have to protect against move to self. Perhaps it's a little counterintuitive, I know, but this is also what you find as the common advice.
Sorry, I didn't actually catch that. If you move to self, is he saying it's fine? It's not, right? Because if you move to self, it deletes its data, and then it moves nothing. Yes, and then it nulls it. So you just kind of like reset the class. That's kind of, honestly, a standard move to reset a class is kind of interesting. No, it's not.
Should mention there is a core guideline. The core guideline says protect yourself. However, there's a note in the core guidelines that says, well, of course we try to be a little defensive. We don't know what could possibly happen, and therefore they take the point, do the if. However, I've never seen it fail anywhere. So this is indeed kind of the canonical form for the move assignment operator.
Okay.
Okay, no except also.
Yeah, I mean, this guy mentions the guidelines here, right? But as he then goes on to say, this guideline may be overprotecting and not strictly necessary. If you assume your user knows what they're doing. Yeah. I know it's a comment from 3 years ago, but if anyone else comes across it, then they can see that additional context.
So don't forget this. And of course we can again assign the integer. This is again purely optional. The default would not do it, so I just leave it. We have again achieved all our goals. The object is now invalid with undefined state. In this case you see 3 phases. The first phase is kind of cleanup. Yes, to some extent a repetition of what you do in the structure. I would sort it, I would structure differently, but yes, it could be a copy of what you do in the structure. Then in phase 2 I again do a member-wise move. Move number 1, move number 2, etc. And phase 3 is again an explicit dealing with pointers. This is something that again you cannot forget. As soon as I make the pointer a unique pointer again, I can omit phase 1 and phase 3. The unique pointer knows full well how to do these operations. And again, if you're left with this one phase, if it's just moving all the members,
Default.
then you're fine with just using the default. So in this case, I could again say default, and again, note this is no except again. So it is much, much easier and much better for you if you can rely on the compiler-generated default. There's one trick that I want to show you, one possible implementation of the move assignment operator that's slightly different. Actually, this is not the move assignment operator anymore. Strictly speaking, it's a copy assignment operator. But if you write it like this, it could actually be both. It's like a copy move assignment operator.
See, this one gets a bit confusing. This is a value, but it's also an R value. Hold on. What actually is the difference between foo and foo this? Are they not both R values? Or bind to R values, rather. They're very different. Foo is a value, it owns the object. Fully constructed. An R value doesn't own anything, binds to an R value. Must refer to something that already exists. But doesn't 5 already exist? Or like, what? So it is a reference, and it can dangle. Indirectly, if it's a temporary. Okay.
I pass the widget by value. By doing this, you can actually just swap the widget internally, and then you're done. If you pass in the assignment an L value, the argument would now be copied. I would use the copy constructor, and then I would swap the copy. If I would have an R value, so some kind of temporary, then for the construction of this temporary object in the object here in the argument, I would use the move constructor. And so I only have to write the move constructor, and here I basically get the move for free. It is not as efficient as if you would write both functions, but it's a nice trick if you just want to quickly cover the operations. So it's kind of a nice fallback if you don't want to sketch out everything right away. All right. Now there's just one more detail that I want to add. When does the compiler add these special member functions? A question. So I have now implemented my own swap. I didn't mention this, I'm sorry.
Did I hear that?
So I now have a swap in the widget. So one argument, not two. In this, okay, now if in case you use move in there, okay, then it suddenly is different. If you add your own swap and if you just say, okay, I swap pointers, I do an int, whatever, then of course it would work. Yeah, so not std swap, your own swap, which you might have anyway. All right, when does the compiler generate these functions? Well, there is a certain, some arcane set of rules. The default move operations are generated if no copy operations or destructor is user defined. And the default copy operations are generated if no move operation is user defined. Well, note, equal default and equal delete officially count as user defined. User defined basically means you mention these functions in your class. You do not necessarily have to implement them yourself, you just write them like here into your class.
If I delete the destructor, will my thing just like not work? I guess that's what a singleton is, isn't it? Also, I noticed that a C++ destructor technically has parameters, just none. Is it possible for it to have parameters?
All right, let's play a little game, 1 minute. Let's assume I have this class X. I want to have a virtual destructor. This is why I write the destructor myself. But the default is entirely fine, so I say equal default.
Yep.
Does the compiler now generate the copy operations? Yes or no? Okay, to make it a little quicker, it says yes. Okay, a couple of people say yes. Anyone with no? So when does the compiler generate copy? The default copy operations are generated if no move operation is user defined. At this point, I did not deal with move at all. So the compiler would generate the copy operations. Very nice. What about the two move operations? No move. There is no move because I have user defined a destructor. So I have to admit, for a virtual class, I don't really see a point of move operations, but for the sake of learning, let's say that we need them and that I want to default them. So now I add the two move operations to my class. What about the two copy operations? Does the compiler generate the two copy operations?
What are these
So,
goofy
no,
rules?
Unfortunately, it does not.
I don't get why these.
Because now I have user defined the two
Like, why
the
do
two
these
move
exist?
operations. So now I have to get them back by defaulting the copy operations too. Now what you see is something called the rule of 5, or something that you see in Core Guideline 21.
Yeah.
If you define or delete any default operation, define or delete them all. So commonly this is known to be the rule of the rule of 5, or also, if you also count the default constructor, the rule of 6. So either you live indeed what I said before by the rule of 0, or you
die.
better define all of them. This is easier for the readers of your code. They will not wonder, do you know about these arcane rules? Are you sure what you're doing? Because indeed, they are a little arcane. All right. That is the basics of move semantics.
What if? Yeah, sorry. How does this apply to like to constructors of a struct? Like, say my struct has 6 members. Can I just default that as well? Okay, I need to revisit that. Because if you look at my library... Oh no, because I wrapped them to standard string. Even then though, if you look at my library, here. Perfect. Like, notice I have this constructor, which literally just passes this stuff into here. Like, is this even necessary? Or like, will it just work anyway? Let's ask Claude. So, is the constructor here actually necessary? Or can I just rely on the default constructor to be efficient? But that's if I want to construct from non-owning views. But that's if what if I actually just want to accept? Ooh. This is fine. This is less fine. But it owns its data. So, okay, so what if I don't need to use non-owning views? Because like I just did it because like I thought I could be efficient, but yeah, and then just move it. Okay, so let me do this now. That's right. We are applying what we have learned. So projects, NCC, NeoVim. I'll zoom in for the culture. Chunk here. Right. So I can delete all this completely. Feels nice. And then instead, for when I call it, which is somewhere, I think here. No, in the Bro, what is this? Find a swap file owned by Kojo while opening file. Use recover. Delete the swap file. How do I delete it? I just take this then. Okay. Right, where was I? Right, so find the chunk constructor. Add chunk. Okay, so first things first, this is a span. What we want is a vector, so we'll just construct one then, right? I'll take a vector. It wouldn't be const. And then I'll send a move. So chunk name, chunk path is a string. Fetch type from map index, fetch path from map index, fetch name. I'm using auto here, which is actually very naughty of me. I shouldn't do that. I should use the explicit types because I don't know what these return. Fetch path string view. Oh, because it's error type. Okay, but still chunk type, and then we go string view and string view. Yeah, because we're dereferencing it. So it's chunk type, string view, string view. No const there. Okay. Then this needs to be converted to a string. To which extent, actually, I'll just do this. I'll move this. I'll move this. Oh, wait, do I use it? No, I don't use it. Oh, whatever. It's fine. Standard string, construct. Standard string, construct. And standard move this. Then in my page, where's my page? Here. We have add chunk, which takes all these arguments, which I don't like. Instead, let me just have it. Well, I can just forward the args, right? I can do a perfect forwarding here. So let me just do that then. C++, perfect forward. Find an example. A simple example, please. So templates. Type name T. I'm not using class. Add chunk. Returns a chunk. So here I'll just put T arg. Hold on. What? How do I use a C++ perfect forward for a constructor with multiple args? Yeah. Yeah. Thought so. So it's type name. Args. I thought it was the other way around. Okay, chunk. Yeah. So the thing just takes args dot args, right? That's for a constructor though. For an argument, yeah. For a function, just do it like this. Do I need T? For a function, do I need T if I know what T should be? Okay, thought so. So, yep, args, return chunk like normal. But then we call chunks.mplaceback, and then this will expand, yep. So we do standard, forward, chunk. No, args. Args. Where's the dot dot dot? At the end. Okay. Yeah, it's kind of hard to wrap your head around, but anyway. So is this correct? Okay. Thought so. So cool. That makes that simpler. Then, whoops, I also need to change the fucking interface of this. Oh right, I don't need to. The rule of 0. And this is fine. So just go ahead and compile this real quick then. See what comes of it. Reader 186. Is it because of this? Yeah. Is encrypted and chunk type equals chunk type binary. Sorry, what's the nesting going on? 1, 2, 3. I was gonna say. He wants to find out. Chunk data, yeah, so saying that this is not a valid construction. How do I construct a vector from a pointer properly? Fuck! Why did you not say... Yo, what the fuck? Discord, no. Okay, thank you. Huh? It returns const. Unfortunately, it's really annoying, but yeah. So the cast kind of has to go there, unfortunately. But standard byte. Let's do auto actually. Auto data pointer equals standard byte data dot get pause data. So I need what? I need the end, start and end. So data pointer and then data pointer plus chunk size. It's fine. Hopefully auto is fine there. I might need to like make it auto pointer or something. Hopefully not though. Hopefully not. Compiles. Nice. So let's see if it runs. It does. I wonder if that fixes. No, I don't have any mistakes there. Anyway, so git add, git commit. Make use of default constructor supremacy and push. I love this. For once I actually understand the fucking language. I can't wait to revisit this when I realize I actually don't understand it and I misunderstood something.
There is just one more core guideline that I want to show. C15 prefers simple and conventional ways of passing information. So you might now wonder, this move semantic, does it appear in many places? Do I have to sprinkle my code with rvalue references? Likely no. It is indeed something that you can consider an optimization. C15 gives a very nice list of conventions that you should use for return values and passing parameters. And if you browse the advice here, you will find move only in 2 places. You'll find this in 2 special cases, in and return copy and in and move from. Special cases, there's an input parameter and I need a copy. In this case, you can optimize. You can optimize based on whether it's L or R value. And in and move from is yet a more special case. I have an in parameter and I know that I move from it. Okay, then this is now with R value references easy to deal with by just taking this as an R value reference. So the place where these R value references creep up is primarily the move constructor and the move assignment operator. This is the 2 functions we use the most often. In other cases, it is primarily for optimization purposes. All right, and with this, we are basically at the end of the first part. And this is what I hope you now feel like. You now feel like, okay, and I thought move is difficult. It's just copying a couple of pointers here, and okay, you have to should not forget to set a couple of pointers to 0, but ultimately it's not that difficult.
It's so simple that you don't have to do any, you don't have to do anything. So yeah, I was just writing constructors for no reason, which is nice. I do want to look at part 2 then. I want to look at it in this video. I mean, it's been what, 4 hours? 4 hours? Jesus Christ! I mean, to be fair, this has been quite the recording. Before I go though, quick look at the comments. F15, okay. I don't like the standard swap method though. Just fucking check, please. Swapping is... Ooh, to be fair, if you're moving... Okay. I do get the swap rationale, okay? Because if you are moving, you're saying the other one is undefined, just like, fuck it, basically. Okay, you know what, to be fair, I do get the swap. In terms of like, we don't care about that thing, we'll just leave it. I wouldn't call it elegant, but it is a useful hack. Cool. So I'm going to have a look here real quick. Do they keep playlists of these things? We have all these different conventions. 26 on these 2 videos, which is more than 0. So let's have a look at that. Yeah, so they have separate playlists for Back to the Basics and Lightning Talks. So the 2019 one from that year, we can look at the There's no Back to the Basics. That's tragedy. Do they have like a general video, like a playlist for Back to the Basics? No, but I can just search Back to the Basics. Ooh, 4 Concepts in C++. This one I definitely want to watch. There was a new move semantics one. That's interesting. I wonder if they recover it every year. Surely not. Okay. Wait, courses. Okay, doesn't really count, does it? So what's this one? So we have 2 things here. Just why you should avoid. Okay, so it's on September. Nice. Where is it? I mean, I surely can't go, but CppCon 2026. It's a week long. Ah, dude. Wait, is it out? It premieres in 23 hours. Holy shit. Good timing. Yeah, I'm gonna watch this. Well, I'll be fucking outside. No, it'll be tomorrow. Yeah. Well, I'll also be out tomorrow. But I'm watching this, dude. This is being fucking awesome. Let me launch Discord. Anyway, it's in the USA. Nah, I can't go then, obviously. Colorado. I don't know where this lag is coming from. Like, obviously I'm streaming OBS and everything, but like, it shouldn't be this terrible. Hype. Casual leaking admin discussion, where right, bro, I can't wait for this. I'm so excited. I still need to watch this at some point, this Lawyer Wild video. The true reason, I mean, it's only 14 minutes, but I just haven't really been in the mood. As weird as that sounds, because I just watched a fucking hour video. Let's simplify the C++ standard library. Why C++ is so slow. Yeah, these lightning talks are quite interesting. I should really just like go through like these entire playlists, honestly. At some point. Let's have a look at 2025. They didn't like categorize them. We got a lot of lightning talks, code reviews. Do we do a back to basics for these two? So how many are there? 152. God damn. I watched this one. This was a nice video. I don't know why it's here twice. It's probably a mistake. Was there any back to basics? I do like the back to basics a lot. They're quite useful. Yeah, here we go. Concepts. Okay, so this was Jeff Garland. Practical reflection. I look forward to seeing that. Yeah, back to basics. Custom allocators. Static inline const expr. That's pretty cool, actually. Pragmatic CMake is interesting. Is that all the back to basics? No, there's way more. C++, love Python. I'd like to see that. AI tool news. Jason Turner. Strings and card sequences. A good video to watch. To make sure you actually understand what the fuck strings are. Honestly, that would be good for like fucking Rust. Where's the Rust called, you know? Actually, maybe there is. Ranges would be good to do. Speaking of Rust. Rust traits runtime polymorphism in C++. Rust traits and style for C++. Okay, that would be really good, actually. That one's going straight to my watch later, because that one's like a high priority video for me to watch. How to refactor code in C++. Friendship. Is that Primogen? The Primesian. No, he's just there for Herbstutter with contracts. Ooh, that I need to see actually as well. He's talking contracts. I already looked at Bjarne's video. Very, very cool. Like concepts and contracts work very hand in hand together. So you got Bjarne and Herb, my two kings, bruv. And then much of that. Okay, so they don't repeat the same back to basics every year, which is nice to hear. Otherwise, it'd be kind of redundant. Okay, I stopped scrolling like 10 seconds ago. Is that it? Right, so what did I... Yeah, so I started this recording looking for fucking obscure C++ features. Then I watched that entire video. But yeah, it was cool. It was a cool video. I learned a lot about move, and now I'm actually quite confident in what an L value is, what an R value is, and what moving does. So to recap, an L value is an addressable value, right? It's something that is addressable. So this can be a variable, because that is addressable. It can be a function, because functions are addressable. And it can even be a string literal, because those are also addressable. They have addresses in, well, within the binary, the static binary. So that's pretty cool. R value, on the other hand, is not addressable. It is temporary. And that's basically how you can think of it. And an X value in particular, I believe, is an R value that has been freshly returned from a function, and such it is expiring. It is like about to expire. Likewise, if you call if you access a member variable as well from a R value, because that R value is temporary, then the thing that you are accessing from it is also an X value. That's what I understand. I mean, it doesn't really matter that much, but like the main thing is L value and R value. And like you have like a pure R value and GL value, which is both of them, but whatever. Then you have move. What standard move does is it doesn't actually move anything. It just casts it to, you cast your thing to an X value and tells the compiler, yo, this is a temporary value, so you might as well move it. And that's basically what it does. And yeah, cool. So then I got this. I got these notes then from Obsidian, right? Tell you what, while I'm here, let me update my Zettelkasten by actually adding these. By adding these notes. So a deep copy copies everything, right? Yeah. A deep copy constructs a completely independent clone of clone. In contrast, to a shallow copy, which does instead keep references, or instead borrow references for complex types. So a deep copy is independent, but a shallow copy is not. But a shallow copy borrows. Sources, back to basics, particularly this section. Yeah, so topics, programming, C++. I mean, it's not really C++ specific anyway, but yeah, programming. So that's one note. Another one. L value and R value, yep. An L value, historically named, since it would typically appear on the, actually, let me skip that. An L value is a value that is addressable, i.e. it has a name. It has a name. Yeah, it has a name. This therefore includes not only variables, but also functions and even string literals. Historically, it is named as it would typically show up on the left side of an assignment operation, but this is no longer so, but this is no longer a useful way to think about it. L equals R. I wonder if Rust uses the same names. Hopefully not. Yeah. Sources. Back to basics. Same thing. Hashtag boom. Fuck me. Hashtag boom. There. Okay. An L value is addressable. This is programming and C++ in particular. Also C, but fuck C. And then, likewise, an R value is a temporary value that is not addressable. Ooh, in fact, sources here. I missed one because there's also this value categories. And I value that's sort of addressable. Unlike an L value. More specifically, there are X values, expiring, and PR values, pure R values. There are x values which are returned directly from functions. Yeah, actually, I'm not even gonna be confident with that. Sources. Back to basics. Historically, it is named as it would typically show up on the right side of an assignment operation. L equals R. R, yeah. But this is no longer a useful way to think about it, as L values can easily also show up on the right. As of C++11, right? Oops. When was R value binding added to C++? 11, yeah. So as of C++11, it is possible to bind an R value exclusively via foo. Note though that this the variable storing this will itself still be an L value. Yeah. Okay, so an R value is temporary. Programming C++. And then standard move. C++'s standard move doesn't actually move anything. Can I put some bold? Yeah. Rather it just casts an L value to an R value, more specifically an X value, to an R value, and which lets the compiler know that the data in an object is movable and should be moved if the compiler is to make optimizations. So again, back to basics. Yeah. So standard move, damn it, standard move is a suggestion to the compiler. This is C++. Okay. What else can I reap from this? Default constructor, yeah, the rule of 0. So in C++, there is the rule of 0 that states that you should aim to use all default constructors and destructor where possible. Conversely, if you are if you need to user define one of them, then you should user define all of them by setting them to by at least setting them to equals default, which includes equals delete. Yeah. This is known as the rule of 6. So hashtag, no. Back to basics. Rule of 0. AKA the rule of 5. The 6 components are the the constructor, copy constructor, copy assignment operator, right? Yeah. Move constructor, move assignment operator, and the destructor. So aim for the rule of 0 in C++. Move constructors and exchange. No accept. Alright, that's actually a good note to add as well. Rule of 0. Furthermore, these should be marked as no accept, or else the compiler will not optimize as intended. Instead, defaulting to pre-C++11 behavior. Yeah. Actually, let me just open that back up and add that as a source as well. Back to basics. No accept. Okay. Quick lines, after motivation is default state. Yeah, that's fine. Okay, cool. And for this, same thing. Nice. So now if I look at my graph, holy moly. Where would I even find this? Okay, so somewhere here. So I got this one, back to basics, points to all these, got an R value, links to standard move, links to lvalues, and the rule of 0, and an R value, and that links to programming, which links to all these other C++ things. Nice. At some point I should really convert these notes too. I mean, at some point I need to sit down and go through all of these, because I have quite a few different notes that should really make their way into my Zettelkasten. And tell you what, after I finish this video, which is where is it? Which is this interview by Bjarne, I will go ahead and also go through my Zettelkasten. But when I do that, I don't know. But it will happen before too long. Otherwise there's too much stuff, right? Also, I just go through my lecture notes for my not my tutorials, my university lecture notes, and convert those before next year, just so I can actually like reap the like not forget everything I learned. It'll be some good summer revision, you could call it. Anyway, that's it then. I just realized I wasn't sharing my screen, was I? So sick. Okay, well, whatever. What I did was I went through my notes, I took them into Zettelkastens, and now if you look at my graph, you can see that around here, the back to basics, I have these notes on R values and so on. And if you look at this one, like the R value one, my notes are atomic, so you can see that there's very little information, but it's all there. Everything I need to know for this thing, right? And if I want to look at a longer one, the rule of 0, you can see I just say the rule of 0 is this thing, the components, and then this little note here, and that's it. So very simple Zettelkasten. And then I was saying how I have all these things to convert, so I'll get on that after I finish watching and taking notes on this video, where Bjarne Strostrup, he talks about something. Well, kind of just everything, like his general history. There's a cool interview that I think more than halfway through. So once I finish it, I'll make these notes and then probably move my inbox as well. I'll get to that at some point. But anyway, yeah, that's the video. What a wild ride! 4 hours and 40 minutes. Started just looking for like obscure C++ features. Ended up trying to learn about standard move, which I did, very good. And then lvalues and R values. Then fucking Eyes of Heaven R got leaked. And there we are. So there you go. Right then. Subscribe for more programming stuff.